And good morning, everyone. Well, I think I'll go for the usual good morning, good afternoon, good evening, wherever you are at this moment. I hope you're all ready to have a great day. And I see the Selma here, so I'm gonna bring some company on stage because it's always better with a bit of company. Pom, pom, pom. And accepting and connecting.
Oops.
Hello. Everything okay on your side?
I can't hear you.
You cannot hear me? Like not at all?
Like something old at that computer, so it affected you.
Okay. Can anyone else in the chat hear me, or no one can actually hear me?
I can't hear myself either.
Oh, you cannot hear yourself either. That is very strange. Hello. Steve says you can hear both of us. Cool. But you can't hear me. Okay. We'll try things again. I guess the computers need to wake up as well, right? But I do not recommend pouring coffee over your computer, hoping it's going to wake it up, because I've done that the other day. Not a good idea.
Yeah.
You're good now? You can hear me?
Yeah.
Yay! Fantastic. Brilliant. Okay, who do we have around?
We have 9 people around.
Yay! People are coming and joining.
Yeah.
So who is up to come on stage and chat with us to start the day or end the day? Because I see that Cooper is around, and I know for a fact that Cooper is in Australia or in the APAC at least hub. So if he wants to come on stage,
in their time zone. So yeah.
Yeah, I was actually just I managed to eavesdrop a little bit on the last sessions that they were having, which was the one by Adina on DataLad, and it's a great talk. It's one of those I actually had the time to watch in its entirety before the event started, and I was like, this is amazing. So it was actually just even fun to re-listen to it because you learn things, and at the same time it's very relaxing. It's a great talk. I'm really looking forward to see to present it to everyone else today. This is gonna be fun. How was your evening yesterday?
I just collapsed.
I wonder why.
I don't know. It was fun. It was really fun to take part in. It was really made me feel so energized. But by the end of the recording and broadcast, I felt like losing the track of everything.
Yeah, definitely. It was the same here, and that's pretty much what I think I tweeted last night before going to bed. I was like, I've been in front of my computer for like 14 hours.
I started
straight. And I was like, and I've been like all over the world with friends and like, in just like so many different countries. But I also feel like I've traveled that distance because I'm exhausted. Oh, that was intense. Oh man.
I remember the America's channel talked about bagels, and I was thinking about the European equivalent of this. We have seen it, but it's not.
Yeah, I think, and also they had a very passionate debate about it yesterday. It was just like you can feel like people people in Montreal and New York really care about their bagels and about the fact that they have like the best ones. Whereas I think in Europe, maybe we don't. There's not that rivalry on like a very specific food item. Well, I mean, yeah, but the French are going to be very annoying about anything that touches to their food. I'm French. I can say that. It's okay. But I don't think it's necessary. I don't. Yeah, but I'm not even sure that that they would argue. Well, I mean, maybe they would. I don't know.
I don't know. The poll about the food and some European culture would be fun. It just occurred to me. I don't know which specific.
Yeah, no, exactly. I'm not exactly sure. I mean, I don't know. Maybe people are going to complain about coffee, but then I think I've traveled in so many different countries, and coffee can be so very different in different countries that I don't even try to compare them. I
Yeah.
just it's just that my definition of coffee has just become just really, really like wide by now. I was just like, okay, anything is coffee, to be honest.
Yeah.
Actually, did I ask everyone to? Did I pull everyone from the previous sessions? I never remember if I did that. Is
If
there a
you
way?
just put the something yes on the screen.
Yeah, I think I did. There's no
Okay.
way to do that after you've started the session, right? Or is there?
No.
Okay.
You just have to put everyone once you
Okay.
are setting the.
Okay. I'm up late eavesdropping from New York, and we do not joke around our bagels. Steve says,
No.
"Yes, yes. I was at your coffee session yesterday morning. Yeah, you are really passionate about that. I mean, I lived in Montreal, so I know the bagel culture there is quite big, but I didn't realize that. And I know that there is a bit of rivalry with like New York, but I didn't know it was just. I was like, wow, they even had a poll on it on Crowdcast. That was just like, okay, this is intense. That was fun. I was actually so busy yesterday that at some point I could not. I literally like had no time to even just go and buy food or make myself some food. So Greg, who is on the Open Science group of OHBM, but he's in the Americas hub, at some point just sends me a direct message on Matamos and was like, give me your address
Yeah.
and like food restrictions, like allergies and stuff like that. I was like, sure, like you're sort of like you're like in the middle of things, like whatever, you do that. You like this, it's like people ask you a question, you answer, you stop thinking. And then, like, I don't know, 15 minutes later, I've got a message from him saying, food is on its way. I'm like, what? So he ordered food for me in Brussels and had it delivered to my place. And I was like, what? Who does that? This is amazing. I was like, that really
Whoa.
saved me. I was brilliant. I was like, oh, wow, you really saved me because I think otherwise I would have crashed earlier than I did, but it was really cool.
I remember someone typed it on the chat about your address and stuff.
Yeah,
Like,
yeah, yeah. You didn't? Yeah, no. But then he like direct messaged me because I was like in the general chat. I was like, huh, what? That's that, yeah. No, but I was very touching as well. I was like, that's the kind of stuff people do for each other in this community.
yeah,
Apparently,
that is
this
really
is
nice.
cool. Yeah, yeah, definitely. Okay. I actually maybe what I'm gonna do. I'm gonna share the document that I have in in mind to sort of organize the intro session of today, and I'm going to share it with everyone. Actually, could I create a call to action? Yes. Can you? Yes. Sorry, give me a couple of seconds.
Okay.
Intro for today. So agenda for intro for today. Yeah, that will do. Okay. And show. Cool. Okay. So now I've added a bit of a button at the bottom here that you can use to sort of uh, figure out what like the different points I think we should talk about or quickly mention in our intro today. So if anyone here in the chat wants to sort of have a look at that and figure out if there are things that maybe we should talk about as well in the intro to make things a bit smoother in general, just feel free to just add a point in there. We'll be happy to just talk about it. Also, I will not be monitoring Mattermost, so if you're trying to reach out to me just right now, this will not work. I'll be a bit busy.
You're live.
Yeah, exactly, right. I'm trying to give like my full attention to what's going on here. Actually, let me even just shut down email and plenty other things. So I'm not even tempted to do anything else. Good.
It also works when you make the broadcast browser full, just you can see yourself.
What was that, sorry?
When you make the browser of the broadcast just full screen, it
Oh,
will be.
okay.
But
Oh yeah,
not
but
further.
I'm usually I always have my like the main stuff I have always have it in full screen anyway, so I don't see the stuff behind. But now I've actually just minimized it, so it's the only trick. Okay, I was telling everyone yesterday about how my camera is just there and not at the top of my screen where it should be. So the only thing I've managed to find to make it look like I'm actually looking at people in the eyes is to make the video like the video screen the window just right above the camera, so I'm forced to look there. But it's still not. It's a bit awkward. Anyway, enough about technical details. To-doom. I'm really tempted to. Should we invite Nikita? Are you awake? And do you feel like coming on stage and tell us a little bit about your project and how it went yesterday? You don't have to. I'm just seeing your name in the chat, and I know that you have a project going on. So if you want to come and chat with us about how it went, feel free to just say hi in the chat, and I will invite you. You're awake. Okay, that's good. Because if not, then you're typing in your sleep, and you should get that checked. Okay, I'll send you an invite. You don't have to come on stage if you don't feel like. I will not take it personally. Cool. Invite accepted.
Hi everyone. Can you hear me?
Hello. We can hear you all right.
There are no much progress because nobody showed up, so I switched a little bit with OSF.
Okay, so you went to Adina's project, is that what you say?
Yeah.
Or okay.
I tried to follow, but it took too much of things which I wasn't aware existed. So I just tried to follow without much contributing.
So because there are too many moving parts in the...
It was the first time to see OSF from inside. It was, and we switched to Data Lab, which was the first. I already heard about it, but well,
it's going to be I think a lot of people on that project will be able to contribute even more after the Data Lab session from today, like the train track one, because it really goes to the basics. It's really good. So what kind of people would you need for your project? Like if someone had sort of like because I know I for a fact know some people who have data sets that should be converted to bids, but there are like, data set that already exist that have a given structure. Should they maybe come to you and you could would it be helpful if they came to you and you try to sort of figure out how to use the tool with their data set, for example?
Actually, from technical things that I wish to do and I'm not able to do, I need an expert of PET, and not an expert of PET, expert of imaging, but not expert just know how to take it, but knows the data formats and how to read them.
That is specific.
Yeah.
Okay.
And also a specialist in MRI. But in case of who knows DICOM.
Right.
Programming is optional, but I need somebody who knows DICOM because I have a small project how to read the metadata from DICOM and determine which kind of MRI it is without any external knowledge.
Yeah. Okay.
Which is not easy and obvious task.
That is not trivial at all. Yeah. Okay.
Elsewhere, just a good Python programmers, because I have a lot of projects that I wish to improve. For example, when you BDify your dataset to specify in some file the structure of your folder, and if, for example, you submit a new subject, he will check if it contains all needed recording and it follows structure, if the subject is complete.
Right. Okay. Gotcha.
Yeah.
So this kind of small stuff and small improvement. Elsewhere, I also welcome everybody who has a small data set he wish BDified, because it's the best way to actually debug the tool if taken on random data sets.
So if someone, if someone has that's what I was thinking. Is like that could be useful for you as well, just like someone who has
my
experience, try the tool.
I played with few data set from Italy. And a few data set of PET, and it worked quite well without too much bugs or too modifications. So I'm actually in quite stable phase of code.
Okie doke. Yes, I see. You are, I think, if I'm correct, you're going to the open science room at OHBM, is that right? Yeah, I think that you went. Ooh, getting some echoes here. I think.
Yeah. No. Oh. Yay. He also asked a question about the unconferences today.
Hey.
Hey.
Hi, everybody.
Yes.
Ooh, exciting. This is my first time on Crowdcast too, so I'm keen to test it out. Thank you. Well, my question, I can open it up, but I was curious how the unconferences will work today. Will it be broadcast on Crowdcast And yeah, what's the go? Talk us through it.
Oh, I'm familiar with a main unconference, which is an unconference, and some unconferences within conferences. So this is more like the second one, as I understood. But it. Mhm, mhm.
Yeah, that's how they go. It seems to be an hour and a half to 3 hours in length. But I mean, sometimes, if you run out of things to talk about after 10 minutes, then that's it. Just there's definitely a longer period allocated for potential discussion. I did.
Yeah. I was
Cool.
searching for the sign up sheet, but I couldn't find the link for the unconferences. Okay. 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 I'll be. Thank you. Thank you. Yes.
Yeah, sure. So I guess I'll be on the more sort of prepared side of the pitches. But I just wanted to introduce everyone here to a project that I've been working on. I actually launched it at SIPS last year, and this will be my first chance to show it to the kind of Cogneuro community. So the project's called Free Our Knowledge, and it's kind of based on the premise that if we act together, then we as a community are much stronger. And it's kind of based on the premise that academia is like this giant collective action problem where it can be difficult to motivate behavioral change as an individual because we're kind of constantly knocking our heads against the system that doesn't reward us for doing these positive behaviors. But if we can get a kind of critical mass of people together that want to do these behaviors together, then we can create a new cultural norm. And that then becomes the new standard that we get judged by. And so the project really started to try and target publishing because I see that as the sort of ultimate collective action problem. We're all trapped into using these archaic print-based journals that are commercially owned, and we don't need to go into all the problems, but they're basically holding back the science we can do. And at the same time, there are these like really like progressive, awesome new online journals that are open access, free to use, but unfortunately not really getting the volume of submissions and support that I think they should be getting. And so like the original campaigns I pitched were kind of basically like around like organizing a critical mass of people to support these new journals so that we can build their reputation and get them to a point where they're self-sustainable and can compete with the traditional journals. That was where the project came from. And now the kind of vision is to just have a more multi-purpose general platform that can motivate any kind of behavioral change. So if you're interested in posting preprints, you could host a campaign or publish a campaign that asks 100 researchers in your field to also post a preprint alongside you. If you want to get more people using the BIDS data structure, then you could post a campaign doing that. Basically, it's kind of, I see it as like the Kickstarter for academic behavioral change. That's my pitch. Yep. Yeah. And it all came from my experience as a ECR, like feeling like I was bullied into doing bad science and having to publish in these journals that I didn't think were doing the best thing for scientists. But then at the same time, we all feel this way, like we all have the same ideals and goals in mind. We just need to organize a bit effectively, I think. Yeah, it's sad. It's sad to see so many brilliant people going by the wayside because our structures aren't supporting us. But yeah, cognitive dissonance is a good way to put it. And I mean, I guess I won't be happy until that tension is at least eased. Like we shouldn't have to choose between being a good scientist and being a successful academic. It's just a ridiculous proposition for us to be. All the touch pains.
Yeah, I have a question for you, Cooper. Sorry. So I really like the idea, and I didn't know that project before. Is there a way for people to see how many people sign up? Like, I know you probably don't want to say who signed up until the big day when it reveals, but is there a count that would just get people excited to see? I don't know.
There is, yeah. I'll put the website in the chat box, but you can actually go to each campaign page and it will show you how many people have signed up already. And in regards to like sort of keeping anonymity, it's actually optional. So when you sign the pledge, you can remain anonymous if you're concerned about blowback for anyone. But if not, you can display your name loud and proud for people to see to motivate other people.
Can you hear crying baby in the background? She's okay. She's okay. She's not alone somewhere. So
can I share screen on Crowdcast? I'm just learning how to use this thing. Oh, a stream is limited to 4 simultaneous video sources.
Yes. Yeah.
Leaving now,
if you want.
Oh no, but you're asking the question. Okay. Let me try and share. It's pretty cool technology. It seems to work pretty well.
Yeah, without so much buttons behind, it allows you to do things.
Not working. Is that working? Can you see my screen?
It just appeared for a second and disappeared.
Interesting. Okay. Oh well. Sorry, I can't share screen, but yeah, if you go to the website, you can see all the. You can click on a campaign and you'll be able to see how many people have signed up.
I'll be looking at it.
I just realized I typed the wrong address. Thanks, Camille. Yeah. Just trying to type and talk and I .com.
Yeah. Yep.
Should I go to make room? Of course. Yeah, it was really good. Had a great chat on bids, which I think you might be getting as well with Dragan. Right? Oh, good. Nice. Yeah, I was doing a bit of juggling between my project channel and the data lad session, so I didn't see too much of that one, unfortunately. But yeah, it's been a really good day. It's been a really good conference. Thanks for putting it together.
Thank you for all the contributions.
It's a real collective action effort. Well, we all need a bit of help sometimes.
Actually, when you're in a situation of getting no help and never getting helped, so out helping is the way of motivating people from all over the world.
Yeah, it's really good to have an event like this because I think so often we feel like really isolated as researchers. And if anything, the system really encourages us to be competitive. So it's really nice to see communities of people coming together and just giving up their time to help out because it all feeds on each other and all of our projects are so interconnected. It's really awesome. Hmm. Hmm. Yeah, and actually, doing it online is amazing because I mean, I never would have been able to make OHBM or the hackathon, whereas now I can connect with you guys in the UK zone and even America. So it's really good that this is going online. I think there's a lot of real great positives about it. I just saw that Johannes is saying, sorry, Remy, not yet around, maybe in 10 minutes.
Are you still? And it's also encouraging for a student perspective because I'm much more familiar with that. When you see a project and in GitHub and you see it's so complicated to jump in, you may be familiar with the organization and the language, but it's hard to just send a pull request. But when you're in this welcoming situation, it's just encouraging student contribution as well. Yeah. Yeah. Yeah.
Absolutely.
My daughter is enjoying the discussion very much. Never. Well, she likes faces. 9 months is very small. I think just faces is fine. She's happy and this looks good. 3 faces, wow. She's clapping. I think that's very, very, very good. Hmm? You like it, Olivia?
So Remy, just to throw back to the conferences, just curious, will they be on Crowdcast 1 and will they be kind of sequentially done, just limited to like a 5-minute kind of slot? Yep. Cool. Yeah, perfect. Sounds good. I will make sure I'm tuned into the Crowdcast around then. I'll be there.
Yeah, we are. Yeah.
There are babies in the chat, but it's just a power discussion.
Ah.
Yeah. Yeah, OHBM is doing some childcare activity, right? Oh, sorry. Hey, thank you for
I just realized that the APAT closing session is starting, so I'm just going to sign off here and then I will catch you guys for... I will. Great. Have a good morning, everyone. I'll see you. Bye.
I'm seeing Katya and many other people. How and Sebastian from EMEA project managers. So there, yeah.
Okay.
Yeah, it's a good time for a coffee. In 2 or 3 minutes. Okay. Yeah. Did you have time to try Gather Town? Wow. Yes. No. I just tried to log in, but I was collapsed and watched Star Wars and imagined that if there would be an option to be send an hologram to all over the world. So yeah, yeah, yeah. Well, yeah. Actually, the room capacity make the things very real, like the real conferences. When you enter, all the seats are taken, so room is full. That's the real conference feeling. Yeah, yeah. I'm clapping. Okay, I'm clapping.
Hey, morning.
Yeah, it sort of is. I also wrote a blog yesterday, some situations. I'm about to press enter for a MetaMost post. The re- on the HBM hackathon one. I can just basically just say what it is. So we have one hackathon project in the EMEA app, and we were started with like 9 people. We lost some along the way, also because some people had different ideas what this project would be about. And now we ended up with 2 or 3 people at the same time. There were 2 more in the American hub. And my old members have asked me to kind of promote this a bit more, that we are still looking for new members because it's very easy to join. We have a very modular project, so you can still come on board. We are all now a bit more on the junior side. So the idea would really be for people that have very little experience. So the project is on EEG, MEG. So this is something you might need to consider that you like that. But it's really low entry level. And the goal in one sentence is basically to be helpful for people that want to get started on pre-registration for EEG or MEG. And I think it's really valuable, especially to have junior people that have exactly this problem and exactly say, I don't know what to do if I want to get started. Maybe even my PI is a bit skeptical, what should I do? And we kind of want to address this problem and create some material to help people along the way. Yeah, already. And I think it's, so what experience brings you is that there are a lot of things you might first forget. And then the next day you realize or something. So it's really like just making a list and people are kind of thinking, I know all of this, but I might have forgotten 1 or 2 of those. So that's already a thing, like just making a short overview. Or I personally feel like I'm aware of a lot of papers that help along the way, but maybe I'm the only one in my group. So this is just collecting papers that or like resources, web pages, that we take for granted, but a lot of other people might not be aware of them.
True.
So just creating some teaching material, basically.
True.
Yes. And we started with that yesterday. So we started collecting existing pre-registrations, and we have a spreadsheet now where we have the links, and we also say what do they do a bit. And the goal was to today, basically now, so from 9 onwards, we have a short meeting to talk about what we do next. But one idea is to look at those that we already have collected a bit closer, and then see what they do. So if I pick a random paper and I say this is my template, would it work? Or is there like quite some variability, and then we kind of have to maybe look at 2 or 3 papers to have a good template? That's what we're gonna do. That's true. That's true. Yeah. Yeah, and even that's just like a problem I already saw, that that the pre-registrations are often quite long, and people just write text, and then you want one setting back, and it's hard to find. You want the filter back, but they spell filter the wrong way, and then you don't find it. Those kind of things. So this is already a problem that we also identified, that it would be nice to have clear structure, clear labels for what you mean, and then it would be much easier to find things back. What you mentioned, so we have pre-registered reports, registered reports that are peer reviewed. So they're sort of, we guess they're accurate in what they do and what they report they do. For the pre-registrations, of course, this is something we would have to look at. If the papers are published, if people actually stick to their original plans or not. Or it would be also interesting to identify struggles. If people maybe are honest and say, we want to do X, but X didn't work, so we have to do it another way. Yes, that's also the idea. So this project was designed to be already very low entry level. So if you're very skilled, that's also good. That's also what we're looking for. But if you so the only thing that we're using right now is our Discord channel and some Google Docs. Yeah, so just text editing. So this should be feasible for most people, I think. And yeah, and that's by design. We can go more difficult if you want. You can also use something else, but the idea was that everybody should be able to participate. Yeah, and if you're interested, then just get in touch with our MetaMost channel. So it's hack HBM hack map MEEG. I'm also gonna post it now, basically, or join our Discord channel. There's also much more material, and there's where we have the discussions. And okay. For now. Yeah. You're Remy here. I know. Okay, thanks for having me on stage.
Yeah. Yeah. Yeah, obviously. Okay. See you.
of, so we try to get all the people who are part of the hackathon to contribute to that page. And we have also tried to design it as a good way for people to make their first pull request. So if you know how to make a pull request, it will take you just not that much time. If you don't know how to make a pull request, there's an issue that explains how to do this. And we'd be very happy if you all could sort of like add your little piece to that page. Just we're trying to just collect one image from each person from like one beautiful place on the planet. So feel free to just add yours there. And conferences, you want to take that one?
Yeah, I can just copy it. Yeah, I pasted the unconferences registration link. The unconferences will be run on the broadcast and will be in the short format of unconferences. So you will be jump on the stage and talk about a thing you just want to talk about, and inform people about contributions and all the things necessary. So please register from the HackMD link I just shared and let us join us.
Yep. And I think we have plenty of space left there, though I wouldn't be surprised if people sign up at the last minute, right? But just in case you want to make sure you have a space there, just maybe sign up now. It's a 45-minute session, and we have 9 slots. We try to keep it to like 5 minutes. That's the idea, more or less. Obviously, if there are only 3 people, each person gets 15 minutes. So that's like a whole conference talk just for you there. The not so unconference is going to be by the end, right? Hack track. Yes, we are getting to the 2 points I wanted to mention. So as Yufang was mentioning earlier in the chat, we do have a Twitter team that has been very active yesterday, during the project pitches, trying to sort of post on Twitter while you gang were sort of like pitching here. The next thing that we have in mind for the Twitter team is that we also want to sort of live tweet the project wrap up. So I think members of the Twitter team should get in touch with the different projects and the project leaders that give them and sort of organize a way that we can create like a couple of tweets to explain what you did and what you're planning to do next on your project. And also add sort of compile a list of the Twitter handles of all the people involved in the project, so we can we can see who contributed to each project. So that's people should be in touch with you today to sort of like organize this. It can also be a good way for you to keep track of what you've done and what you're planning to do next, and so on and so forth. So it's a sort of good way to document the hackathon as it's happening. So yeah, I think that sort of covers all the things we wanted to tell you about. Anything else? No? Any other questions? Someone wants to say something? Anything unclear? Now's the time to ask. Let us know.
Would it be necessary to remind the code of conduct and all the things?
Yep, definitely. So remember that we do have a code of conduct. Can someone just post a link to it? It should be on the, actually, if you go on the website of the hackathon, you have a COC for code of conduct in the
I'll be copying just seconds.
Cool. So it's the OHBM code of conduct. Remember that we are, this is the rules we are following for the hackathon. And there's links there to sort of report anonymously any breach on the code of conduct. But I would also like to remind people that there are, you can get in touch with Robert Oostenwold and Echil if for anything that could be related to a code of conduct violation. So do not hesitate to get in touch with them. Remember that we are here for you, and we want to make this space just a welcoming environment. So please just do not hesitate to get in touch. Thank you.
Thank you. After the train track talks uploaded anywhere after the stream, George Thomas asked.
Oh, that's a question? Okay, yes, thanks. Actually, very good question, because a few people have been asking this.
Yeah.
So, yes, we are planning to have all the talks online after the event. So far, we sort of been using the YouTube channel as a backup in case something doesn't work. The reason why we have not made all those videos public yet is because we have not yet arranged with all the train track instructors on how to share and just getting consent to do things properly. So we right now they're not public yet, but if there's a problem with our train track, we can just send you to YouTube so you can watch it. But I know that, for example, some of the train track instructors have already posted their videos on their own YouTube channel. So I know that Stefan Bollmann has posted the Git and GitHub YouTube video on YouTube, so it's already there. And I know that Adina has already posted the data lad on YouTube as well. So some things is already there, but I think we're going to try to have everything nicely set up in a playlist on YouTube in our channel, and to have all of that released. So yes, definitely all of that content will be shared. And I've also, I think, updated the page that has all the information for the event. I've already updated the train track section with a link to an OSF folder that has all the slides that we already have, or with links to the different websites that you might need for some of the train track sessions. So for example, the next one has as an OSF project that it links to, and a GitHub repository as well, for example, and the Data Lad one has a link to the handbook by data that Adina actually wrote. So you're actually getting a course, but the person who literally wrote the handbook on Data Lad. And there is also a link to the slides that Adina will be using, or has used, but because she's already shot the video, but you haven't seen it yet. This is time travel in a weird way. Okay. Yes. So yes, content will be made available afterwards for sure. Any other questions? Nope.
If not, I'll be setting up the next session.
Okay, so I will end this, and I will let you log in with the account of our official account, and I can let you set everything up. Also, maybe as a warning to people, I think the way it's going to, because we cannot have people on stage when we're broadcasting, the video will just start bit right away, so it might be a bit dry. Sorry about that. So we won't get to introduce. I mean, maybe you could introduce, but it could be a bit more complicated. But I guess we can introduce the next one now.
Yeah, it will be safe. So it will be talking about the dividing and conquering M scripts.
Yeah.
It will be an introduction about MATLAB.
Yeah, so if you've ever had to or ever ended up writing a script that's like 1,000 lines long, and you got lost into it, this is the session for you. It's pretty much about refactoring, which, if you're not familiar with the concept of refactoring, is when you take code that is still will do the same thing, but it's much more, it's cleaner, it's better organized, it's easier to maintain and to come back to and to understand what you've been doing. So that's it will be about. It is centered around MATLAB and Octave, but I would like to say that a lot of the concepts around refactoring can apply to pretty much any programming language. Okay, don't get me started. MATLAB is not a programming language. We're not having this debate here.
Okay.
But like the purists are going to say, no, it's not a language. Blah, blah, blah. It doesn't have an official grammar. No, we're not having this conversation. But I just want to sort of explain that even if you're not a MATLAB user, I would recommend you attend this session if you've never had proper training on how to write a good code, because the ideas in there are like apply to just almost any kind of programming. So just go. Do not hesitate to join that session. Cool. Okay. Are
One
we all
thing-
good to go? Yes,
Yes,
go
good.
for it.
One quick reminder, if you see the black screen, don't be worried. I'll be starting with a black screen, and there will be some little delay, so be patient. Thank you.
Yes. And if any case we have a problem, we have a YouTube backup in case it doesn't work. So it should be smoother than yesterday, right?
Yeah.
Okay, good. All right.
All fingers
So
crossed.
yeah, exactly. I hope you all have a good day, good hacking, good training, and we'll talk to you later. See you.
Hello everyone, I'm Agah Karakuzu from Polytechnic Montreal. In this session, I'll try guiding you through some steps to divide and conquer a really complex M script, which is written in MATLAB, but also Octave compatible. I'm a PhD student at Neuropoly Research Lab, co-PI'd by my supervisor Nicolas Tikov and Julian Coenadat. My PhD project is about standardization of quantitative MRI methods, which is used for microstructural brain imaging, and I'm trying to achieve this through open source software development. I got involved in this project with QMR Lab, which is a software for fitting and simulating QMRI data. It is natively developed in MATLAB, but also fully Octave compatible. And in Montreal, I'm surrounded by people who love contributing to the community by sharing their code, sharing their data, organizing courses to teach open research practices in neuroscience, such as Brainhack School by Pierre Belek. And this open environment helped me find out super cool tools about open software development, and which are then translated into creating quantitative MRI pipelines that are transparent from scanner to publication. And I'm also lucky that almost every research branch from our lab ends up developing an open source software. So these are some of the tools developed by the team of Julian Coenadat, in case you're interested: SCT for spinal cord imaging, Axon DeepSec for automatic segmentation of histology images using deep learning, and also shimming toolbox to correct for MRI field inhomogeneities. Apart from my PhD work, I am trying to contribute to science communication as much as I can for MRM highlights, MR Pulse, and also for OHBM blog. Today, I'll show you how we can take a long and complex M script and divide it into modular pieces and wrap some good software practices around it. And in an attempt to make this online session a little bit less dry, I created a hypothetical case. And let me give you a public disclaimer: names, characters, and even some of the algorithms involved in this scenario are total products of imagination. Meet Professor Janice. She is the PI of a neuroimaging lab, and she is recently interested in the use of MRI-based microstructural characterization in structural connectivity. And to get the ball rolling, she scans 2 healthy subjects and collects diffusion-weighted images along with 2 structural images, one with magnetization transfer pulse on and one without. Her idea is to calculate a metric called magnetization transfer ratio to inform structural connectome with myelin content. And at the time, a new summer intern visits the lab. His name is Jim. And Jim finds the idea of using MRI to explore human brain organization quite exciting, and he has some experience in MATLAB. Seeing how eager Jim is, Professor Janice says, "Okay, I will give you some pre-processed data, and I want you to use DSI Studio to reconstruct corpus callosum fibers, and then use inverse distance weighted 8-neighbor interpolation to visualize magnetization transfer ratio values along fibers in MATLAB." Jim says, "Oh God, what I've done with my summer." With summertime sadness playing on repeat in the background, Jim got comfortable working with MRI data after some hassle and wrote some code that actually gets the work done. And his script, Jim_MTR, performs the processing for 2 subjects and visualizes the results. I mean, which fulfills the expectations of Professor Janice from a summer student. But 6 months later, Professor Janice collected more MTR data and decided to put together a grant application for this project idea. She would like to add Jim's figures to the grant application, but she would also like to make it reproducible with code on GitHub, data on OSF, and results in Binder. And after looking at Jim's code, she gives up and asks master student Eda to refactor Jim's code and make it more open sciencey. Eda happily takes on the task to refactor this code, but at the same time, when she looks at the code, she says, "Oh, Jim, what have you done?" So today, I'll try to emulate what Eda would do and start by exploring the code dependencies and executing the code locally both on MATLAB and Octave. Then I'll use a brand new tool by Remy Gao, which is Check My Code, to see how complex is the code written by Jim with some numbers. Then I'll create a clean Git repo, inspect the code to get rid of duplications, unnecessary conditional checks, and cryptic variable names, and I'll write some modular functions. While doing this, I'll try to introduce some tips and tricks that can improve brevity and the performance of your MATLAB code, such as fun operations. These are MATLAB-style shorthands that use anonymous functions to boost iterative processes, something similar to list comprehensions in Python. And you should definitely check this series of tweets by Joe Mezzaro's his 30 days of MATLAB tips he wished he had known in grad school. And I'll also touch upon a thing called implicit expansion, known as broadcasting in Octave. And these are the metrics and array expansions that automatically happen, but may break your code if your MATLAB version is lower than R2016B or your Octave is older than 3.6. So it's definitely worth knowing these version-dependent differences. So once we finish refactoring the code, I'll write some unit tests using Mox unit framework to have simultaneous Octave and MATLAB compatibility. And then we will configure a GitHub action that runs these tests at each push to the repo. And when we have our tests ready, we will Dockerize the environment and put our code in Jupyter notebooks and make them executable online using Binder. If the time permits, I'll teach you how to configure a simple GitHub action that can build and push a Docker image for every release of your code. Of course, all these things that I just mentioned previously required Octave because there is a proprietary license issue with MATLAB. But there is a way to create your own MATLAB-capable continuous integration service using Azure self-hosted agents. And it is much easier than it sounds, honestly. I wrote a blog post and explained every single detail. You can find it on qmrlab.org. We should also ask ourselves the question, when people look at our code, will they see what we are doing? And these people will probably include ourselves after a month or so because we'll forget what we've written. And styling is really important to write clear scripts. You can find the PDF of this book, MATLAB Style Guidelines 2.0 by Richard Johnson online. It is a really useful resource, and I'll do my best to stick with these guidelines in the course. I'd like to thank all my colleagues in Neuropoly Lab, with special thanks to Tommy Boszkowski because he provided the data. I also like to thank Elizabeth Dupre and Greg Kiar for being there for every open source team event. And finally to Lisa Levitis and Remy Gao for productively organizing this event in such a crazy time of uncertainty. So now let's download the Jim's code and get our hands dirty and start refactoring this spaghetti script. These are the resources that I used to create these nice visuals. Downloaded Jim's code from Open Science Framework, and when we take a look at the folder, we see one function that probably functions like the main, which is gym_mtr.m. And inside of it, there is a variable defined subjects, which equals 2, and then there is a for loop that iterates over it and displays processing subject number. And then there is an eval function call. That is something you may want to avoid at all costs. Do not use it if that's the only option. And in this case, this is just used to CD, which is to navigate into different folders based on the II iterator coming from the for loop. And then there is gym_analyze, probably the function that does the main thing. Yeah, it plots some figures, and then the script uses find object to get the figure objects and save them as PNG files. When it finishes iterating over all folders, it says this done and closes all and clears all. And in the subject folder, we have 2 PNG images as we expected. These are the outputs. Corpus callosum 500 TR keys, corpus callosum tractography with 500 fibers in it. Change PTC courses, Klein. Yeah, this is the interpolation function, which is given to Jim by one of the PhD students in the lab because they pity it in working on all these complicated stuff on a summer internship. And this is the gym_analyze.m, the script that we are going to divide and conquer. There is empty off and empty on images to calculate that magnetization transfer ratio that, as I said in the presentation. And there is octave data that is kept in another folder, but this has less number of tracks in it. And text file that contains a fine transformation and 2 external functions for reading and plotting fiber tracts. In the S2 folder, I see same functions repeating with different data. This is not a good practice at all. Your code base should be capable of dealing with different repositories. You don't have to copy paste them under different repos and then make an external call to them from a for loop to do all these operations on it. And on top of that, we have a different file here called diff_fa, diffusion fractional anisotropy image. We don't know why it exists. It's a bit encryptic. Anyway, now I'm going to take a look at the MATLAB's project reports. For this session, I'll be using MATLAB R2018B as my main editor. I'm using a MacBook Pro. I'm on OS X. So these functions are highly useful. First thing that I want to check is the dependency report for this project. And here it says gym_mtr depends on gym_analyze. We already know that. So let's go take a look at the folder, subject folder, and get the dependency report again. Now we have more details. So I'm interested in this gym_analyze, and it tells me that there is one unknown dependency, which is load untouched knee. So probably Jim has this function saved to his default search path, and he forget adding it to the code library when he was uploading it to the Open Science Framework. Now we gotta find this function online and edit so that we can use it. We can see that there are other dependencies on change PTS courses, the interpolation function, track reading and plotting. And it says, yeah, this also shows which MATLAB toolboxes you're going to need to run this function. In this case, we'll need image processing toolbox. And then the second useful report is the code analyzer report. And for gym_analyze, we have 4 messages. It says, using clear all usually decreases code performance and it's often unnecessary. Yes, it is. We have some error warnings from the linter, such as do not use this printf. You can replace it with this function. And it says the value assigned to variable trc key sfa might be unused. Another encrypted variable name that is dangling. And it also says that the variable tmp appears to change size on every loop iteration. Consider pre-allocating for speed, which is one of the good practices that you may want to follow in MATLAB. Do not update your variables on the fly. Create empty variables, initialize them, and then assign values into them. And finally, another useful report is a help report. So for Gym Analyze, there are no description line, no help, no example, no see also line, no copyright line, which means good luck refactoring that. So let's try running this main script, gym_mtr. Processing subject 1, but you can't process it because load untouched knee is missing. Okay. Now we have no option but finding it online. So I saved this nifty manipulation functions that are also Octave friendly on this GitHub repo called monifty. I'm just simply going to clone this into gymntr. So once I clone them, I need to add them to the path. So set add path monifty. Now we have that function, and let's run gymntr again. So yeah, now it was able to read the nifty files, specified the origin of it. In this case it was 0. Interesting. It loaded 500 tracts, and then now it's interpolating magnetization transfer ratio values along those streamlines. So this normally was supposed to take about 20-25 seconds, but now I'm recording screen, it's probably gonna take 30 seconds. As a side note, with this 500 tracts, you may not wanna even try it on Octave, because it is taking 30 seconds in MATLAB, but it's going to take 16 minutes on Octave 5.2.0, at least on OS X. There are several reasons why Octave is slow. I will talk about that a bit later on. Yeah, now it's processing the second subject. I was planning to show you figures in 3D, but close all and clear all. This is what it does. So let's go back to our folders and check our outputs from S1. We clearly see that these tracks are not well aligned with the brain image, and also the MTR values shows that the half of the tracks are just noise. And this one was probably just to check if the fibers are aligned with the brain. In the first case, apparently they were, but then they weren't. For subject 2, yeah, looks like fibers are better aligned. It is also displayed on FA images with no interpolation. I don't know why. And yeah, this is the alignment check with the MT1 image. Now, before we analyze gymanalyze.m, it is time to run this new cool tool by Remiga, which is called check my code. Now it's going to go through all the M files in this current directory, and it's going to give us a score called Maccabi code complexity score. If it is higher than 15, we definitely need to consider refactoring that code. And this function also is going to tell if the code has any comments in it. So let's see. All right, so what I'm interested in the most is gymanalyze.m. It has the complexity score of 28 and percentage of comments is 3%. We have a difficult task ahead. When we take a look at the other functions, This is given to Jim by a lab colleague. It has, yeah, it's better. It's 13, at least it's acceptable, and it has 10% comments. This is an external function. This change PTS courses, whatever it is, it has the code complexity of 3 and it has a bit more comments in it. So that's something. It also says that you should way too complex, refactor them for these functions. So yeah. Now let's take a look at gymanalyze.m. It starts with close all, clear all. There is no need to do this. You may want to avoid that. You should only deal with variables that you're interested in, and in case someone else has some other variables in their workspace, you will also get rid of them, because this M script doesn't have a function description at the very beginning, which means that it is going to be using the base workspace, the workspace for the variables of MATLAB. Anyway, so then it defines three structs for this one. There is also FA, empty on, empty off, and FA. And it gets the list of all the files with .ni and something else, probably .ni and .ni.gz. And then if there are no nifty files, it's going to throw an error saying that no empty on file, as if it's the only file that may not exist. And then after, if there are some files, it will loop over them. And then do a complicated check. If these files are compressed, it is going to decompress them. For if it's empty on, then it's going to decompress it and load untouched.ni, that empty on file, into the empty underscore on variable. It's going to repeat the same thing for empty off and FA if they are zipped. And if directory includes some nifty files but they are not compressed, then it's just going to go ahead, find them and read them into now different types of now it's going to read it into struct. So even at the first conditional code block, we have some inconsistencies. Anyway, we will take some notes down and leave. So we will say that this section is to check if files are compressed or not, or if they are nifty with specific names. Moving on with the inspection, we see that emptyon.prefix field is assigned with some metadata from the struct that is created by the loadNifty function. And this is the point where it actually displayed the origin from Q offset X, Y, and Z. It gets the origin information into the struct later on, and then it's also reading the dimensions from the Nifty metadata. And then here we see an operation. Oh, we have a comment here. Thank you, Jim. It says that flip dimensions twice, but why? We don't know. We are yet to understand it. So yeah, it casts the data into double format. It is important if you are dealing with quantitative images especially. And then first flips the second dimension and then flips the first dimension and gets the size. And wait, it's doing the exact same thing it did for the empty on, for empty off. So let's put this duplication notice to make our life easier. So I said duplication start, it read the metadata, double flip, and then put this mysterious empty off direction hard-coded value, and then we see that the same thing is happening for again FA, Philips FA, and here it is. Okay, I changed my screen recording tool. Now I'm using Loom and hope that this is going to be better. Anyway, so here we see a new struct definition, plot, and then into this plot structure there is a new field assignment for slice, which is set to 30. using function round. There is no meaning to use round. S30 is already round, so there was round here. Why? Probably there was a variable that Jim got rid of and it was a leftover function. Then it defines a new field with capital Z, which simply defines once matrix multiplied by 30 to create an in-plane slice on which we are going to display our image, and also created a mesh grid for that. So this is simply create AGK domain to plot. And then we see that it fetches metadata from MT on image, origin, spacing, and it also initializes new fields, this time lowercase x, y, and z, which is probably going to store transformed indexes. And then along those in-plane axes, it performs a for loop and calls this change PTS courses. So obviously this function is responsible for transforming points from IGK to XYZ when you pass this magic argument. So let's say this is for IGK to XYZ, and it is assigning values to the fields that were described here. And yeah, we keep seeing this plot.direction, this identity matrix many times. So this is hard-coded. So I will take a note. There is a hard-coded identity matrix throughout the script. We'll find that out. And then it takes these intensity from empty on, calls this map to gray function to map grayscale values, and then finally calls figure and uses surf, because if you'd like to display your image in real world coordinates in 3D, you need to use surface plot. So use surface plot to display image in world coordinates, and then hold on, which means that expect something to be displayed on it. Now we are reading yet another file, which is .trk read fibers, and again it gets the list of all the fibers with trk extension. This can be trk or trk.gz, and if empty it throws an error, blah blah blah. It's again trying to understand if it's compressed. Should I decompress it or should I read it directly? Oh god, it's too many unnecessary file checks. And then finally, when it manages to read that file, it says that number to string length of tracks has been loaded. So this is the specific line of code that told us 500 tracks has been loaded, which also means that the coordinates of the streamlines are stored in this trc key as stores streamline coordinates. And then here we are reading some other file, which is, yeah, you see what we had in the folder was transform.txt, but obviously Jim had the same file in transform.mat format, so we don't have transform anymore. Read these files. Now we see that there are some operations happening on the affine transformation matrix. It takes the fourth column, the first 3 rows of the fourth column, which is the translational component of an affine transformation matrix, and scales it with the diagonals of the orientation matrix. So it is kind of, yeah, update translational components of the affine matrix. then set scale factor to identity. So yeah, it is just using the information within matrix to change the spatial location of the fibers in world coordinates, but it doesn't want to scale it up or down. It is trying to keep the size of the tracks the same, and then copies those tracks into another variable which is named FA. And then here, yeah, it is doing some kind of transformation to the fibers. So apply modified transformation to the original fibers. And here tracks FA is transformed differently. Apply transformation to the original fibers again with different transformation. We probably won't need this at all because our main purpose is to do interpolation using MTR values, not this domain. Then it finally plots fibers, and then another duplication to do the same thing on FA image. I'll skip that part. And here we calculate MTR images. By the way, I inserted these comments. It is a super simple calculation. Here, this is how you get your MTR image. MT on minus MT off, absolute value of it divided by MT off gives you the magnetization transfer contrast that you need to understand the myelin content. Now, once you have this image, you need to interpolate MTR values on streamlines, and you achieve this by calling this inverse distance weighted 3D interpolation function with tracts and MTR, and then you finally loop over every single fiber and every single node again to apply this interpolation and save new scalars as the fourth column of the tracts matrix. Normally it was it had 3 columns for X, Y, and Z, and once we calculate new scalars, we are just going to write them into fourth column so that it's going to be recognized as a scalar. And this time when we are plotting when we are calling the TRQ plot function, if you may notice, we pass header, tracts, 2 empty arguments, whatever they are, and scalar first. So this means that use the first scalar that is written into the tract matrix and display the new fibers. So this is how we were getting the images saved in, let me find them quickly, Brainhack, GMMTR, subject to, so yeah, these images. These are streamlines with MTR values written. Please don't let this complexity intimidate you, because I wrote this code myself 2 days ago, and when I was trying to refactor it, even I was not able to understand what I did at some parts of the code. But this was kind of exactly the point. How can I take a 330 lines long code and create something modular, something useful out of it? And to do that, sometimes you may need to read the same code, the whole thing, a few times. But now I have a better feeling of its main components, and I think I'm ready to go ahead and create an empty repo to take some notes about what kind of refactoring I'm going to do. So I'm creating a new folder called refactor gym, and now I'm going to create an empty Git repository by having Git init. So now there is a version control in this folder. Now I'd like to add some files and give this folder a structure, and I'll start by putting some empty files. The first one is going to be refactor.md, the file that I'm going to take notes about what kind of refactoring I'm going to do, and I'm going to put this at the base of the repo. And then I'm also, of course, going to create my readme.md file. Another good practice is to keep a change log. And I would like to keep my scripts in a folder called src, which stands for source. So I also create that folder, make their src. Another folder to keep external files such as load nifty, or those files responsible for reading and plotting tracks. So any code that you'd like to use but you didn't write. And these are probably living in another GitHub repositories. So I'm also going to show you how to add those modules as sub-modules, which is super useful to make your code base easier to maintain. Now we are back to our MATLAB editor because we are going to write our first function, which is going to be getData.m. So let's save the script under source directory, getData.m. As you noticed, I follow the camel case because this is what is suggested by the style guidelines if you're writing a MATLAB code. The same applies for variable names. So the first thing that I'm going to do is to copy paste a header comment template, which is here. This is, let's write a super brief description. This script is used to read necessary data and header to perform MTR analysis. We are going to describe the syntax here, and I like this function to give me two outputs. The first one is data and the other one is header, and as inputs this is going to take empty on image, empty off image, some fibers, and we are also going to add this var argument, which means that variable input arguments that we are going to use in parsing them with input parser. And for inputs, let's type empty on, this is nifty file. I'm just gonna put super brief descriptions. Empty of, which is again a nifty file, and the third one is the fibers. This is going to be a trk file, and it's going to give me two outputs: data, which is going to be a struct containing empty on, empty off, and fibers. Header is going to be a struct again containing metadata that belongs to empty on, empty off, and fibers. Made a lot of typos. And these parameters include, we'll come to that once we are done with this M file. It says other M files required none in order to, we can just simply skip these parts right now. If you also have some other functions you want people to see, you can add them here, see also. And you may want to put your email address here so that people can reach out to you if they have any questions regarding your code. And this is June 2020. And yeah, now we can start writing our function. as I did above, I'll quickly define it by function data header, which is going to give a get data empty on, empty off, fibers and variable input arguments. All right, so let's first thing first, I'd like to create an input parser so that I can make sure that the variables passed by users are going to be valid, and I have an organized way to access everything. In MATLAB, you achieve this by first constructing an object that belongs to the class input parser, and you achieve this doing by simply p equals input parser. That's it. And as I write my code, I'm going to insert lots of comments to make it easier for people who are going to read this in the future. So I'll say create input parser object, and I also like putting this kind of separators to make following code easier. And now I'm going to set my input conditions, and I'm going to allow only the compressed Nifty files for the sake of this examples. So I'll say only the compressed Nifty inputs, which means this. And now I'm going to write some anonymous functions to create validation rules. So let me show you how to write anonymous functions. So for Nifty validation, let's call that variable, well, ni, and this equals, you put this at x, and you use this x as a proxy for the checks that are going to be performed in another functions. I think it's going to become more clear as I write it. So the first condition is that I want this empty on to exist as a file. So I put x and put file here. And I also want it to be a Nifty file. So I'm just going to check the last 3 letters in the file name to see if it's NII. And to add it as another condition, I'm just going to add this strict comparison. I'll take x and from and -2 to and, which is the last 3 letters, and see if it is ni. So I created a condition as an anonymous function to validate my Nifty inputs. I'm going to do the same for TRK files. So now I'm going to say allow only the compressed TRK files, and here I'm going to call this valid TRK. I'm just trying to maintain consistent variable names throughout the script, and in this case I want this to be a file again, along with the condition of having the extension TRK. Great, so this is super cool. We can create customized input conditions without using any if statements that makes things a bit more complicated. And this input parser can be used in Octave also, which is super nice. Now we are going to tell input parser which inputs are going to be required. And required arguments are positional. So if you see variable names explicitly declared in the function prototype, it means that these are going to be required inputs. And if you have, by a rule of thumb, if you have more than 3 variables, you may want to add them as a struct, so that one struct can contain multiple fields that can be processed by your script. Otherwise, your function prototype gets really long for too many required arguments. So now let's add required parameters. and check for types. And to do that, we will use required function, and we are going to pass our input parser as the first argument. The second one, I'm going to put empty on here, as I described in the function prototype. Empty on was the first variable. And then the third argument is going to define which checks are going to be performed on this input file, and I'm going to put valid me, and that's it. And I'm going to do the same thing for empty off, and this is going to be subjected to the same nifty validation rules with as empty on image did. And finally, required fibers, and this is going to be valid tr key. Once I'm done with required parameters, I'm going to add some optional parameters, and in this case I'd like to pass this hard-coded identity matrix that was present throughout the script. So apparently I need that information somewhere in the following functions, so I'm going to pass it as an optional argument. And to do that, I'm going to use a function called addParameter. So I'm just quickly type a comment at optional inputs. So there is also another function called addOptional, but if you use this, it is going to break compatibility with Octave. So instead of this, just use addParameter and and I'm going to name it orientation. And the cool thing is that I can set a default value. So if user do not pass a value with as orientation, I'm going to have an identity matrix here, and my validation rule is going to be his matrix. So if you have just one condition to validate your input, you can pass it right away as an argument inside of this addParameter function. It makes your life easier. Now finally, we are going to parse these input. Parse parameters. And to do that, we are going to call a function parse. We're going to pass our object. And now we are going to use these as they are one by one. So empty on, empty off, and fibers. And we also have some variable input arguments. We are going to pass it as a vector. So it's done like this because it's a list of cells. If you want to vectorize it, you gotta use curly braces. So here we go. We just wrote an input parser that would take, I don't know, at least 100 lines of code if we were to use if, else, and check for different types of conditions. This is super concise, and once you get used to it, it is a really good addition. And you may also ask the question, should I write an input parser for every type of function? The answer is no. So if your function is going to be consumed within a for loop, this checks can create an unnecessary computational overhead, and you may want to avoid it. So if you need performance, you shouldn't add these input parsers. So it is meant for the functions that are going to be used by human, not by other software pieces. Let's see this input parser in action. And to do that, first I need to add everything in my current directory to the search path. And to do that, I'm going to simply do add path, and to include subfolder, you can add this generate path. And here I'm going to pass pwd, which means the current directory, and everything in this directory is going to be added to the search path. And then to test this, I can go and check a data folder. So let's navigate to this directory, and let's copy this so that we remember the function prototype nicely. First time I'm trying to run this, it's going to throw me an error because I didn't complete the whole function, and I am asking this function to return two variables called data and header. So, but I'm going to pass correct input names in it, and here we have corpus callosum 500.tr key. So when I call it, it's going to say argument data, and maybe others are not assigned during the call to get data. But I'd like to see if my parser works. To do that, I'm going to set a breakpoint in my code by just simply clicking here. You see that red dot means that your code is going to start executing line by line, and it's going to stop here, and all the variables in the workspace of this function is going to be accessible through your command window. So let's add one more breakpoint here to show you how it works. So now when I call that function once again, and here you can see this little green arrow, it says that it is waiting for my next instruction at this line. And when I click step, it is going to go step by step. And when I click continue, it's going to run everything until the next breakpoint, which is the line where we call the parse function. So now here, if you see this K before these symbols, it means that you are in debug mode. And when I copy paste this parse and execute that line, now if everything went right, I should be able to see my inputs in p.results. For example, for empty on, it gives me empty on.me. For empty off or .fibers, you can see the fiber file name. Or you remember we also passed an optional argument, orientation, but I didn't do any I didn't add any input arguments for that, so that it's just going to show me the default variable. To quit from debug mode, you can simply type db quit here, or in this window there is quit debugging button that appears. So let's do one more call to this function and see how can we pass an optional argument to this function. And the name of that argument is going to be orientation. So I will just add orientation and put some, I don't know, random it gotta be a matrix, so this should work. So here we are again, hit this breakpoint, and it parsed, and when we see our results.orientation, now we will see the custom metrics that we passed instead of the default value. Let's quit from the debug mode and go back to the working directory, just so that you know we are at that point. Okay. So now once I have a good way of receiving my inputs, now I gotta start initializing correct objects to store them. And to do that, I'm going to use structs, because we have both data, different types of data, different types of metadata, and I like to keep them organized using different fields in two structs. One of them is going to be data, and the second one is gonna be header. And while initializing structs, I could have done this: data equals struct, but this won't give any clue to people what I'm going to put into this struct. So instead of following that convention, I'm going to explicitly specify which field names are going to be present in my struct. So struct, and the first one is going to be empty on. I don't know what how big that matrix is gonna be, so that I'm just going to leave this part empty. If you are sure about the type of data that's going to be loaded in, you can also specify empty empty matrices or vectors to make your code more performant. The second one is going to be empty of, going to receive some image, and we're also going to receive fibers, which is going to be empty again. So let's say initialize struct for data. Now we initialized our outputs as structs that we know going to have the fields of empty on, empty off, and fibers. Now I'd like to add some sub-functions to this function that only pertains to this get data functionality. First of them is going to be get nifty header, and the second one is going to be get flip nifty image, because we are not just going to read the image, but we'd like to flip it. The reason is that when you read nifty data into MATLAB, they have different descriptions of origins. One of them is on the upper left and the other one is on the lower left corner. So you need to flip images to see them in the correct orientation. So I'll just copy paste these functions for get nifty header. I'll just copy paste it. It's simply getting a nifty file and giving us a header output, and it is using load nifty header function, and it is assigning more useful names to the other fields. So it takes offset x, y, z, for example, and puts it into header out.origin. And then the second function that I'd like to add here is to flip nifty image with some descriptions in it as well. So it says due to differences in MATLAB versus nifty orientation, blah blah. It's just image double load nifty data, and then flip these dimensions as it was done in the GIMS code. All right, now I'm going to use these functions to assign values to the variables that I just initiated. So for empty on, the header is going to be header dot empty on equals get nifty header, and I'm going to get the file name from my parser, which is p.results.empty on. Then I'm gonna do the same thing for empty off, because empty off is also a nifty file. And now I'm also going to do something similar to read my data, but this time it's going to be data.empty on equals get what's the name of the function, get flip ni image, again p.results.empty on. I'm going to copy paste the same thing for empty off. So as you can see, I'm started to showing a pattern when I'm doing same thing multiple times and just changing variable names. Whenever you feel like you're repeating something, you're duplicating function calls, but the only thing that is changing variable names, and especially if they are changing in a systematic way as we are doing here, you should probably write a simple for loop to handle this kind of input case, right? So obviously the determinant factor here is that if my inputs are nifty, I can loop through this p.results.empty on field and see if I can call them. But how am I gonna know these are going to be associated with nifty files? I'm just going to simply create a list called nifty list, and it's going to be a list of cells, and the first one is going to be empty on, the second one is going to be empty off. Oops. Right? And then I'm going to iterate these items and look for it in the objects of p.results. So I'm going to say for I, this is how you should define your iterators, by the way. The most common one you will see is II, which is definitely not understandable. Or if you use I, MATLAB is using the same notation for complex numbers, so you may want to avoid it. So I'm just going to simply say I is going to start from 1, and it's going to go to the length of my nifty list. As you can see, there is a consistency between the name of the iterator and the list that it's going to iterate over. And I'm going to get the current name. I just say name is going to be nifty list. You gotta use curly braces again to access the index stored in a cell, and it's going to be take my iterator. Now I'm going to simply check if this is not empty, if p dot results. So now I'm going to check if p dot results contain something that belongs to the nifty list. But how am I going to take that one string and use it as dynamically accessing to a field in a struct? To do that in MATLAB, you can simply use parentheses, and then when you type name here, it will do that check for you. So this is really useful. I use it a lot. So if you know these tricks, you are not going to feel the urge to use eval or some other kind of circumventing functions to do these operations. So now I set my condition. So then if this happens, I'm just going to say that, okay, now I know that this is a nifty file, and I have some simple rules to read nifty files. So I'm just going to read header dot name is going to be equal to get nifty header, in this case p dot results dot name, right? And remember that I also like to inject some other metadata, which was called orientation, and this is a great place to do that because I just want to access them in nifty files. So I'm just going to say header dot name dot orientation. Now I'm adding a new subfield to that, and it's going to be p dot results dot orientation. I hope this is not boring. I'm just repeating things on hoping that they are going to become more clear. And finally, I also like to store the file name that is passed to the input, which is useful, and that's going to be the name itself. And finally, I'm going to read the data dot name. Oops, not like this, like this. Data dot name is going to be equal get flip nifty image p dot results dot name. Yeah, that's it. Now we can delete these lines and we don't have any repetition. And another cool thing is that this is scalable. For example, in future, I'd like to use the same function, but I will have other nifty files required. Let's say FA. I just need to do this, nothing more. If I add FA here and to my function prototype, my function is just going to simply read it without any other additions. So this is also good for modularity. And the last thing that we need to do is to read inputs for the structs, fibers, and it has just one simple function, which is trkey read. And here in trkey fibers, how did we define that name? As we called that p dot results dot fibers, and here header dot fibers and data dot fibers. So that's it. We wrote a function finally with header input parser by initializing our outputs and then reading our nifty files. Read nifty. I'm going to add more comments to these codes later on, so when you're reading them from a repo, I hope that this is going to be more clear. And on purpose, I'm going to leave many of these functions without any header information or any comments, and kindly ask you to make pull requests to my repository to create a more understandable code base so that we can at least some interactivity. Yeah, that's it. We have our first function, get data. So I took advantage of recording this online and edit all other functions that I'd like to create during my refactoring process under the source directory. Because otherwise it would be really boring to show you what to do specifically in each of them. So first, let's go back to the getData.m and remember that there were some functions such as this low nifty header or functions to read our fibers that were added externally to Jim's code. So what I'd like to do is to find those repos and add them as submodules to our repo. And I collected all those relevant links. Remember that we had an external directory here. This is where we are going to host all those functions as submodules. And to add a submodule, I just simply say git submodule add, and I will now copy paste the repository URL for check my code. And then I am going to say where I am going to put this function in my repository. In this case, I want to place this under external folder, and I'll call the name of that folder check my code, and I pass recursive, oops, not this one, and use shallow submodules so that I don't need every branch and every commit. I just want to get the latest one commit. So that now it's cloning it into the external check my code. And I also would like to add nifty library, so I'm going to do the same thing, git submodule add this external slash MATLAB Octave nifty, I will call this, and recursive shallow submodules. And there is one more library. This is for reading and writing our fibers. Again, git submodule add this to external, I don't know, let's call it trkey tools, recursive shallow submodule. Now it's fetching the repo. Cool. Let's see now what we have in our external directory. As you can see, we have MATLAB Octave nifty, check my code with a typo as usual, and track tools, and everything we want is available here. But the thing is, let's see which submodules we have, and it is git submodule helper list. Yes, so it says that we have 3 submodules added with these specific commit hashes to our repository, and when we push it, it is really not going to push them to GitHub as files, but it's just going to push this information so that GitHub is going to know that these are submodules, and it's going to point to other repositories. So when you're cloning a repo that has submodules, when you do git clone URL, you will only get the codes that belong to that repo. If you'd like to clone repository with submodules, you need to do git clone URL -- recursive. Just additional information. So now I'm going back to my editor now that I have my dependencies. And external, I need to add these to my search path. So again, add path. Cool. Now I'm going to try my get data function and see what it gives. And to do that, I need to navigate to a directory that contains some data. I have some data here, yes. And let's see. Empty on dot me and empty off, and for disclosure 500.tr key. All right. So now we called our function and we have two variables. One of them is data and the second one is header. Let's see what we have in data. Data dot, we see fibers, empty on and empty off. Let's see what do we have in data dot empty on, and I don't know, here. Cool. We have a brain image. So yeah, and also in the header information, we again have the exact same field name. So there is this consistency that's going to make our life much easier. Header.empty on, for example, has fields name, orientation, origin, size, and spacing. If you remember, we injected these metadata while loading the file names. And now when we get origin, yeah, this origin for this data was 000. This is nice. So I want to show you some other things regarding functions before writing tests. And there's something I added in this transform fibers function. So before in Jim's repo, we had this nested for loops to iterate over every array in this fibers variable. So maybe I should show you this. Fibers is going to be data.fibers, and when we check the type of the fibers, it's an struct array. And to access elements of an struct array, let's say this trkey1 equals, you need to call it in this fashion. So we know that truck1 is a fiber that has 193 nodes with these coordinates. So in this part of the code, I am looping through the length of fibers, and in each fiber I'm also looping through nodes. And one bad thing about looping too much is that your code on Octave is going to become much more slower. This is because of two reasons. One of them is that to do vector and matrix operations, by default MATLAB is using something called Intel's Math kernel library, whereas Octave is using something open source, so it's a bit slower than what Intel provides. And the second important thing is that MATLAB has a better architecture to understand loop logics in your code so that it can execute them faster. Anyway, these are probably too much detail. So instead of writing a nested loop, I used array_fun. So the function of this array_fun is to execute a function on each element of an array. In this case, our array is a struct array. And as you can see here, we have that anonymous function again. So it tells that, okay, perform this action on X, which is fibers, and assign its output to this variable called tmp. And here I defined another small function to do that transformation. You can write the function between these parentheses, but if it's something a bit longer, you should better write it here. Now I will take a closer look at this array_fun at the line 45. If you remember in the presentation, I told you that there are fun functions and there was a series of blog posts about it. So I think this is a good place to talk about them a bit. Before we refactor the code, this operation, that was a nested for loop to transform fibers, is now performed by a single line of code, which is called array fun. So first, let's see how it's going to operate by placing a breakpoint at line 53 and calling the necessary functions. First, I will read the data and the affine transformation that I need to call this function, transform fibers, and then I will call the function itself by passing fibers, origin information, and the affine transform to it. And we see that the function executed in 0.01 seconds, which is pretty fast. And how long would it take if we were to execute this function in an old fashion? Let's see it. So yeah, the new one tenfolded the old one in terms of speed. But this may not be always the case with array function. Probably there was something worse going on in the code that we refactored, so that we see that array function improved the performance a lot. But this may not be the generic case all the time. Anyway, I'm going to add a lot of tips and tricks about how to improve the performance of your MATLAB code in this transformfibers.m. You can find them in the repository, and that content is going to include things like vectorization. The most important thing is pre-allocation, implicit expansion, and fun functions. So anyway, what is this array fun doing in here? We see that it begins with an anonymous function description again. It says that, okay, I'm going to run this function on X as a proxy of fibers variable. And then we also see uniform output false. So you set this to false if the anonymous function is going to return outputs that are not equal in size, so that the array fun is going to store them as a cell array. But if you set this to true, then you assume that every single return from that function is going to be equal in size. And here, our anonymous function is calling a subfunction called TFM, which is described here. I did this just to keep this line shorter. And remember that there is always a trade-off between the speed and the readability of your code. Sometimes while you're trying to optimize performance too much, you may sacrifice lots of clarity. So you may also want to avoid that. It's really a matter of trying to find the fine tuning. Anyway, this array fun steps into this TFM, and this is where I'd like to talk about this implicit expansion. So let's see it in action. I'll call that, not this one. Yeah, I will quick from this debug mode first. And all right. Now we are in this particular line where implicit expansion happens. So when we'll take a look at this code, single line of code, it does matrix times transform. So our matrix in here is 110 by 3, and normally you can multiply this by a 3 by 3 matrix. So that's normally happens. Let's see what it gives. Let's see, it's equals to C. And yeah, variable C is going to be again 110 by 3. But then here's the weird thing. Size of this variable is 1 by 3, and somehow we can add C with this 1 by 3 variable, and we get a result. Let's see, output equals C plus one. As you can see, it gave us another variable, which is 110 by 3. So MATLAB understood that we are trying to expand the 1 by 3 vector along this singleton dimension to match the size of this 110 by 3 matrix. Maybe I can give you a simpler example. If A were equal to 1, 1, 2, 3, 4, 5, 6, and B was something like 10, 10, 10. And I would be able to do this A plus B, which would give me this. This is also the equivalent of VSX fun and et plus AB. So this function is available for MATLAB versions older than R2016B. But if I try to do this A plus B in MATLAB R2015A, let's say, it's going to break. The same applies for Octave for versions 3.6.0. After putting this much effort in refactoring a spaghetti code into something modular, you probably don't want anyone else to push a commit and break your code, or you also don't want to introduce a bug that changes the destiny of everything in your repository. To prevent that, we are going to write some unit tests, which are an important part of the continuous integration process, that not only ensures that the new changes that you introduce to your repo is not going to break anything, but you can also make sure that the magnitude of changes in your outputs are not going to exceed a certain threshold, because you may not receive a runtime error, but it wouldn't make any sense if your new inputs are, I don't know, like 2 times higher than what they were before. To introduce tests to our repo, I am going to use this repository called MoxUnit. It is a XUnit framework for MATLAB and Octave. Let me quickly check defining MoxUnit tests using this specific framework. We need to start our test with this header, so I copied it. I'm going to create a new function. I'm going to test our get data function. So I'm going to name this get data test. Let's save this under test directory. I already put our test data here, but normally this data is not going to be a part of your repository, because you shouldn't store big binaries in a Git repository. It's not a good practice. Instead, I'm going to push these files to Open Science Framework, And when I'm running these tests on a remote server, I'm going to add necessary steps to tell which data to download before running my tests. But right now, let's just keep it under test folder to see how testing works locally. So I just saved it. That's the header part. The only thing that you need to change is this function name, otherwise MATLAB is going to complain. Now I'm going to write a function, let's say function test loader. And every time I'm going to tell it where's my data. So to do that, I'm going to define a new variable called data directory. And in this case, it's in just a subfolder named test data. And I'm also going to add this file sep, which is / if MATLAB is running on Ubuntu, and / if it's running on a Windows system. And then let's put a message. Testing get data function, so we know what's running while I'm looking at the log. Now I'm going to call my get data function with empty on, empty off, and test fibers.trkey. And yeah, let's save it and run it. On my computer, I have MoxUnit library saved to my default path, but this is not going to be a part of this repo because we will be using GitHub Actions that already has this MoxUnit test. So I created something comprehensive to run Octave tests on GitHub Actions. I forked this from this repository, but I added some other functionalities to be able to load some Octave packages, add some data directory, and some other cool features that can make testing with Octave on GitHub much better. Yeah, I defined this little test. I'm going to call MoxUnit run tests. Great, it passed because we just merely called the function and didn't do anything more. Now let's see if these outputs are exactly the same with what I saved in the test data directory. And here I have my test data. This is test get data.mat. Let's see with if variables of data and header in this previously saved mat file is going to be equal to the new ones. I'll clear that from the scope. And to do that, I of course need to first load them. So I'm going to call them saved. And then I'm going to put some assertion tests that are also a part of the MoxUnit framework. This is called assert equal. And here I called my data loaded and header loaded. These are the new ones. I'm going to check if data loaded dot fibers are equal to save dot data dot fibers. I'm going to repeat the same thing for other fields in my data, which is empty on and save dot data dot empty on. Let's run our test again and see if it's going to pass. So yeah, it passed again. But if I do to this data somewhere in between, let's say we introduced a new change during a commit, and it did something like this. Data loaded dot empty on now equals to data loaded dot empty on plus 1. So now this assertion test is going to fail. As you can see, it says that these elements are not equal. First input this and double, and yeah, this is going to prevent us from doing wrong things while we are while we are pushing new commits to our repository. I'm not going to show you how to write one test per function. You can find all the tests in the repository, and I will add a lot of comments and detailed explanations in the README file, and I'll be also ready to answer your questions. You can feel free to open GitHub issues regarding anything that I explained up to this point, because it's probably too much to digest in one session, but I really would like to do my best to show you all everything that is possible that you can do with MATLAB and Octave. So now in the next step, we are going to add our tests in GitHub Actions. This is going to be the repository that I'm going to provide you for Brainhack 2020. It's called EDA Organized because remember the name of the master student was EDA, who refactored the code and everything. So let's take a look at this project structure again. Of course, I added many more things, and yeah, let's start with this refactoring.md to remember what we were up to. So we said that we will divide and conquer, and we did the divide part. We took that one long script and created all these other functions, despite that I just only showed you how to do it for get data. Otherwise, it's impossible to do it in about an hour. And then we have the conquer part. And for this one, we create a test data that I already did and gave it to you, but I can definitely answer your questions regarding how to create a test data. For example, one important thing is that you should generally put a part of your data, because you don't want your continuous integration server to run tests for a long time, because I told you that running the same function on Octave for 500 fibers takes about 15-16 minutes. It is too much for a test step. Instead, if you provide it with 10 fibers, it should happen in 2 or 3 minutes, which is quite acceptable for a CI test. And then upload test data to OSF, which I already also did. Write tests per function and ensure that they perform assertion checks. This is also done. Tests will be placed in a folder named tests. Check. And then configure a GitHub action to run tests with coverage in Octave. Now this is what we are going to do. Let me show you. Let's see what we have under test directory first. As you can see now, we have one test per function, and in each one of them I call the related function. In this one it's change coordinate system, and once I get the outputs from it, I do assertion tests to see if they are consistent with the old ones. Now I want these tests to run whenever I push a commit to this repository, and I want these beautiful badges showing me what's going on. So right now when I take a look at it, it says that there is code coverage of 100%. So this means that the code that you write, every single line of that code is hit by some unit tests. So you covered the whole basis of your repository with tests. And the second badge is telling us that the continuous integration is passing. This information is coming from GitHub. And the second one is telling you that Azure pipeline succeeded. So this is also a continuous integration continuous integration test, which was run in MATLAB. So I will begin with CI tests on Octave. Just show me the badge, thank you. Let's see this. Yeah. Okay. So you can see that I pushed many commits to this repo, and some of them were passed, some of them were failing, depending on what kind of changes I was doing to prepare this repository. let's take a look at one of the tests, one of the recent ones that passed, and see what kind of output it gives. So there is a build process, and here this is the log. So it's going to create a test environment which is based on a Docker image from QMR Lab Octave CI version 4.2.2. I assume that you have some little information about Docker containers. And then I check out this repository because after you push a commit, you need to check out that repo to be able to test latest changes. Then there is a step download and extract test data. I will show you how this is done. I put a script called download test data.sh. It's a simple shell script. And then it is running Agah Karakuzu Mox unit action master. This is doing the testing using that Mox unit framework and doing the coverage test using Mockup. As you can see, I loaded image and IO packages. They have an asterisk next to them. And here it is. Change coordinate system test passed. Get data passed. And every single one of our tests passed. And it says, okay, pass 6. Unit test succeeded. Yay. And then once this test is completed, it creates an XML file and it is passed to code coverage. I'm also going to show how to do this. And it returns information to the badge in our README repository. But how do we set this up? For GitHub Actions, you create a special directory, which is .github/workflows in your repo. And here you put some YAML files. In this one, I named MoxUnit YAML, but you can name it anything you like. And this is the description. So it says, on each push to the master branch, I'm going to start a job, which is named build, and this job is going to run on a Ubuntu machine. And the steps are going to include check out the repository with submodules. This is important in our case because we have some submodules. Let me show them just to quickly remind you and see how they look on GitHub. So normal folders that you place look like this, whereas submodules has this arrow. So, and they are associated with some certain commits. This is a nice way to understand if a directory contains submodules or default files. So once it checks out our repo, in the next step, it's going to download and extract test data. And I'm passing a variable from GitHub Workspace, whatever it is. I can explain it later. And I'm running a single command, sh download test data.sh. Let me show you this download test data. Here it is. So it's super simple. It's if this variable, this environment variable is available, and no, if this variable is not available, then it assumes that you're downloading this data to your local machine. If not, it is downloading data for GitHub Actions. And this is the download link. The rest is just wget or curl depending on which one of them are available. You can definitely take this shell script, use it as a template, and just change this download link when you're doing for something for your own. So let's visit this repo on OSF, of course, without that. This is Jim's MTR analysis open science framework project that I set up. And you can find all the relevant data in here under a data directory. There's actual data with 2 subject and also the test data, which is a bit smaller than the original one. Okay, once we downloaded and extracted our test data to a specific directory that is defined in the shell script, and in the next step, we are calling this mocks unit action on our repository to do the testing. All we need to do is to create this descriptions. We say uses Agah Karakuzu mocks unit at master with source src as source data. And to test data, we are going to use the files that are downloaded under test data. Octave packages that would like to load our image and IO. And we have some external dependencies that would like to add to our path. We just simply pass it here. And if we also want coverage, why not? We should want a test coverage. We just say, okay, with coverage true, and give the XML file a name, coverage XML. And then in the next action step, we are going to call the one by the codecov. This is codecov.io. You should have an account here to log in. It's just more than enough if you have a GitHub repository, and as you can see, a organized repo is associated with this, and it's totally free. Here I use this token, but you don't have to use it. This is not required for public repositories. And here you just need to say, okay, which XML file should this service check? It is coverage.xml, and then the rest is just fixed, and it gets the thing done to get your coverage report. It uploads that XML file on your account, and you can see that 100% of our repository is covered for every single file sitting on the source directory. And you can also see the lines that are hit one by these tests. So it's really good. Let's say you didn't cover some of the lines, you will know exactly what to do to get more test coverage. So that's it. All it takes is to place a well-defined YAML file under .github under workflows in mocksunit.yaml or runmytest.yaml. And then when you push a commit, let's push a commit to the README file. These are the badges. This is a test commit. Let's see it in action. I'm just going to commit these changes. And when I click Actions tab, you will see the commit. And when you click it, you can follow the whole process. Sometimes it queues, may take a few minutes to set up and start a job, but it's usually super fast. Now it's pulling a Docker image that is about 500 megabytes, and it's usually happening super fast. And then it's going to run these actions and complete our tests. If I push anything that breaks it, we will see that continuous integration test is failing. I also told you that there is another test running on MATLAB site, and this is using the self-hosted agent that I set up in one of the computers in our lab. But let's see what it does. If you'd like to have something like this, you will need to set up your own server, and I will also put the link to my blog post explaining how to do that. So MATLAB test has already finished because it's 10 times faster than it is in Octave. And here we also have check my code reports, so you can see the code complexities of the new additions that we put. As you can see, these are all acceptable, but this one, because I didn't put much effort in that one. get data has subfunctions has code complexity of 5.1. It has 47% of comments. So we can definitely make these much better. And for the tests, we see that all the tests passed. So now we know that this code is going to run on MATLAB, and it's also going to run on Octave for the tested versions, of course. And to set up these Azure pipelines, you also put a YAML file at the base of your repo. In this case, you'll just say trigger this workflow when there's an event on master. And as pull, it says default, but this is a Ubuntu workstation in our lab. And then for the steps, it checks out the repository again with submodules true and just run this MATLAB script to do the test. And that's it.
All right. So we divided our script into smaller functions, and each of them are now responsible with a certain task. Then we started conquering this spaghetti code by writing unit tests for each function and creating a GitHub repository. Now we have version control. And then we hooked a continuous integration service to our repository using GitHub Actions. It's here, one with Octave, and we see that it's passing. And it also uses code coverage. So it shows that the 100% of all the codes that we written so far are covered by tests. We add one more service, this time running continuous integration tests in MATLAB using the Azure self-hosted agents. And it also has this beautiful check my code functionality. I think now our code deserves a good user interface that can be executed online using Binder. And this interface is, of course, Jupyter Notebooks. I will add all the installation instructions in this README file later on about how to run your MATLAB Octave code in a Jupyter Notebook, or how to get them running in Octave, in Docker, or using repo to Docker and everything. You can find all the instructions in this repo later on. But when it comes to creating environment descriptions to use Octave and Binder, Docker files are my favorite solution because I already created and pushed some Docker images to Docker Hub to make my life easier, because I'm working on Octave a lot. We are creating interactive tutorials and everything, and I don't want to deal with different dependencies in each and every time. So I created both Python and Octave environments that are living together in a Docker image. And each time I like to create a Binder link, I point to that Docker image. Another solution with Binder Hub to describe an environment is to use configuration files. So these are some custom files such as requirements.txt, environment.yaml, or runtime.txt and such. So when you point a repository to Binder Hub, two directories are checked. The first one is the root of your repository, and the second one, the second option is to have a folder called Binder. So I use this option to keep things a bit more organized. And as you can see, I provided a Docker file and another file called postbuild on purpose, because when you provide Binder with a Docker file, every other configuration file is ignored, such as postbuild. But of course, there are some tricks that you can pull inside of your Docker file to make them a part of your environment build. So let's see what's inside this Docker file. This first from instruction is really important, because it tells Docker builder which foundation to use. Here I am using QMR Labs Octave Jupyter Notebook image, which comes with Octave 4.2.2, Octave kernel to use Octave in notebooks, some Octave packages that is useful for neuroimaging, such as IO image optimization and statistics toolbox. And I also add some interactive visualization libraries in Python, such as Plotly, and it has SciPy, Pandas, and some other useful Python tools to read MATLAB data into Python as well. And the second instruction we see is add, and as you can see, it says add point homework. So this tells Docker to copy everything in the repo to the work folder under home directory. And then the run command you see here on the 16th line is to execute bash commands during the build. As in, you can think this as running a command in your Ubuntu terminal. It does basically the same thing. Here I read this post build file line by line and execute every command in it. This is just to download the data from Open Science Framework and decompress them to the environment. I will show you that script as well. And finally, we set a working directory to the folder where our content lives. So this is going to be the folder that Jupyter Hub is going to serve when our binder session starts. And that's it. I mean, all it takes is 5 lines. It's actually 4 lines or 3 lines. You don't really need to add your data into your Docker image to get a fully functional Octave notebook running on cloud. Yeah, just let me quickly show you this post build script. I usually don't add too much data in my Docker images, or I don't put too much data in the GitHub repository. It's not a good practice. Normally I would use this post build as actually a post build script that runs after Docker image is completed. But in this case, I made an exception because our data is not that big. It's about 40-50 megabytes. So I first download the input data using wget and then unzip that. And the third one, I included test data as well in case you'd like to play with it. All right, so to binderize this repo, now we will copy paste this URL. And we are going to visit mybinder.org, one of the binder service providers. You can see other options here. There is one on GSS, Turing Institute, or OVH. They are all running different binder instances. And here I will paste this repo, the repo URL, and you can easily copy your link from here and paste it to your README file so that people will know that that repository has binder. So let's hit this launch button and it will start a build. And we can see build logs here. It already cached many things from my build, including the Docker image and everything. So this is going to happen pretty fast. As you can see now, it's downloading our data. It finished building it and it's already pushing the image. Oh, it happened super fast. But as it is building, I will show you my notebooks from my local. But let's remember how it all started. With this long, unnecessarily complicated, and if I may say, ugly script with 0 commands. And now we have a beautiful notebook that can execute on cloud, and it has environment descriptions and everything in it with modular functions. So I think this was a nice showcase about how can we divide and conquer a script. But I added disclaimers left and right about the sanity of this analysis. Just please remember that I created this repo and every single line of code in it to showcase a simple scenario. So please do not use this particular special alignment or interpolation approach in a pipeline. but if you're willing to add quantitative MRI in your work, just tell me, I can point you to much better resources. So let's run our code. The first tell is to turn off Octave's warnings because it's super verbose. It likes printing lots of warning messages that you normally don't see in MATLAB. To keep my cell outputs clean, once I'm done with developing the notebook, I run this one particular command. And then we need to navigate to the home Jovian work directory first in this notebook because that's where our init-env initializing script lives. This is responsible for adding everything we need to the Octave search path and also loading Octave packages that we need. So let's run this. As you can see, it loaded struct, iostats, and some other packages and successfully added everything to system path. And now I'm going to use the data located under a subject2 directory of ADAD data that is automatically pulled to the Jupyter Hub session as we described in our Docker file. So I described my data directory. Sorry, this is much slower than it's normally is. Yeah. And now remember the get data function. We will now read our data from data directory we just specified, which are empty on, empty off, and 50 corpus callosum fibers because this is running in Octave. And if we were to load the one with 500 tracks in it, it would execute in about 15 minutes, which is really not nice. But there are lots of practices in the code, so you can always try making it faster. So it loaded our data. Let's see what's in the empty on and empty on image. As you can see, it's a simple images plot to see two slices. And then we read our affine transformation from transform.txt. If you remember, we were transforming our fibers. Let's do it. And then, yeah, I will show the the tracks that are loaded on a single slice, but in Octave these 3D plots are not showing really good if you're on a notebook, so it's just going to give me something super funny. And in the meantime, I'd like to talk about another good software practice, which is not to reinvent the wheel. Yeah, this is how it looks like, but don't worry, I have a much better visualization surprise for you. So even for the simplest quantitative MRI methods, there are different ways that you can calculate a quantitative map. And even for MTR, which is just a ratio, some people multiply it with 100, some people take absolute values, some people abstract the MT on from off versus off from on. So if there is a package to do this kind of analysis, I try to include their function into my repo. And in this case, remember that we created this Docker image from QMR Labs Docker image. So we can use QMR Lab easily to calculate our MTR image. So here we loaded data and fit, and it also has an inbuilt function to display outputs in a nice dynamic range because printing quantitative maps can be a bit tricky. And it also gives you a function to save fit results along with a new Nifty file that is in the same space as with one of the parent files. And it's also a really good practice to specify when you're saving something to which. Now we have our MTR data as a variable. And now we are going to do this inverse distant weighted interpolation with MTR. This is probably going to take some time to do it, and then we are going to save our fibers. Yeah, so this is it. We can easily expand this analysis for multi-subjects, given that now we have good functions responsible for one specific task. So yeah, it finished interpolation, and now I'm going to save them in .mat format. There is one important thing. While you're saving .mat files with Octave, you need to pass this -mat 7 binary arguments. Otherwise, you won't be able to read math files you write in Octave in MATLAB. So yeah, this is the operation. So now let's take a look at the interactive visualizations. For this one, I loaded the .mat files I saved before, and I saved one from MATLAB by interpolating 500 tracks so that we have a better visual. I loaded few Python libraries in here, SciPy, NumPy, and Plotly to read and manipulate these images. So I'm not going to go through this function. It is doing something pretty similar what I was doing in the MATLAB function. And this is what we get. A 3D interactive plot that shows nodal MTR values interpolated on the fibers, and when we hover we can actually see MTR values along those fibers and everything. It's really good. But here, this was the reason why I was really cautious about warning you not to use this script in your analysis. As you can see, these are corpus callosum fibers, but in the interpolated region I clearly see brain ventricle patterns. So probably my fibers were not good registered to the anatomical image along the longitudinal axis. So this is, anyway, for nodal MTR values, and we can also visualize average MTR values per tract in this fashion, and we can explore them one by one. So yeah, that's it. I hope this is going to be useful. I will add one last component to the repository, which is to build and push a Docker image to Docker Hub every time you make a release. But I'm not going to talk about specific of it right now. Yeah, if you're interested in how to do that kind of thing after you read my instructions, I'm more than happy to help you. I think this was, yeah, that's it. This is the end of my talk. Thank you so much, and looking forward to meeting you online soon.
The questions that asked earlier.
All right. Do other people
Yes.
see us at the moment, or
Yes, we are live, and
okay.
43 people are seeing
the questions that asked
page.
earlier, right?
I can hear myself from other computers, so I shouldn't be doing that. Yeah. First question asked to you from Ceren Battal. Told that, can you tell me again the difference between git clone and git submodules? You explained within comments, but if you want to elaborate on that, feel free.
Yeah, I mean, the comment-wise, what git clone and git submodule does are totally different. Git clone is to download a remote repository to your local machine, whereas git submodules, which is usually used with git add submodules, to add other GitHub repositories as a part of your project.
Yeah. you.
And
Second-
yeah, the only important thing with git clone and submodule is that if a repository that includes, if you're cloning a repository that includes submodules, you need to pass -- recursive argument to your git clone call so that your download is going to include all those submodules. Otherwise, they will be omitted.
Oh, yeah, that's the trick. Octo handles, it's a question from Remy. Octo handles input parser exactly the same way. I think I ran into issues in the past. Octo version issue. And you elaborated on the answers, but I'm not sure about understanding that.
I did, but I can talk about a bit more about the keeping your MATLAB and Octave up to date with each other. Despite that, the Octave is an open source clone of MATLAB. When you're trying to implement new things, you will always run into some issues. Some of the functions won't be available. So if that's the case, if you know how to write that function, you should definitely go back and contribute to Octave to that functionality. If not, you may find some workaround solutions to do that in Octave by writing small scripts. And sometimes, for example, for this input parsers, it's available both on Octave and MATLAB, but there are some differences between two of them. So you should really try and fail to understand if the same thing is happening on both ends. This is one of the reasons why, if you're able to do your continuous integration tests both on Octave and MATLAB and see if they provide the similar outputs in both ends. So yeah, that's a bit more advanced use case probably. But yeah, mostly input parsers are compatible between MATLAB and Octave right now.
Thank you. I'm going through the questions in the order of the ask. So we are going back to submodules, and Remy said, why do people hate submodules so much?
Do people hate it? I mean, I definitely don't hate submodules. If anything, adding something to your repository as a submodule is a much better way to stick with the open source development practices. So I can definitely go ahead and clone a repository to my local, get rid of the Git directories in it, and keep the license and copy paste everything into my repo. But then how am I going to know that which exact version or at which exact commit I copy pasted into my repository? That information may be totally lost because you may not have an explicit declaration of your versions in the repository. So for some people put a version.txt at the root of their repo. I'm one of them. But if that doesn't exist and you copy pasted everything and then you found a bug in it, but you don't exactly know which commit to trace back. So to that end, using submodules is useful. And I think it's also a good way to give credit to other people in your repo. You can just click to that folder and go and check what they are developing these days.
Really cool. Remy also asked, you mentioned using camel case. I know the answer to that one, but what other types of cases are there and why should we use them?
So in MATLAB, it's mostly camel cases, and there are a few exceptions to that. For example, while you're defining a struct, the first letter is capitalized as well, and then the fields are going to follow the camel case. And there are cases that you may want to use all capitals if you're declaring some global variables, but you shouldn't too much. Yeah, all these things are really explained in super good detail in the MATLAB Styles Guideline 2.0. I provided the link as an answer to that question, by the way.
Thank you. And this is his last question. Yeah. So you're basically using submodules to cover the lack of MATLAB package manager and environment manager.
Yeah. MATLAB now has something called projects. So you can definitely develop a MATLAB code and other people can easily add it to their MATLAB project to build on top of that or use it as a submodule. But can you still hear me? I think you're disconnected, or I am disconnected. Hello.
You are live. Sorry, I just did something wrong. Hey.
Okay. Can you hear me now?
Yes. You were live all the time. I just
okay. Your connection. Okay.
Yeah.
but I usually choose not to stick with that project structure because it's not Octave friendly sometimes. So if you're trying to do things in MATLAB way too much, then you will sacrifice some Octave compatibility. And I always want to keep that because I want to give an easy for people to execute my scripts online, even if it's smaller, even if it's working with a sub portion of the data, it doesn't matter. So yeah, you can create MATLAB projects, but you should also think about Octave.
Okay.
What was the MATLAB link? Let me find it.
Yeah, that's the link. And if there are any other questions, please ask. These were the questions asked during the first part of the video. And I checked that there's no additional questions for the second part. So feel free to ask your questions right now.
Yeah, I was actually a bit surprised not to receive any questions from all the continuous integration and other parts. So yeah, there should be some questions. If not, if everything was clear, that's amazing. That's usually not the case.
It was true, but it's really one of the straightforward talks that I listened, because it's normally really boring to watch people coding, but you're all so fun. I enjoyed the talk.
Really, I thought that I was really boring. Towards at the end of the second hour, I thought that people would fall asleep. Even I had to drink lots of coffee to keep myself awake.
Thank you. It's been really amazing to keep you in the chat. So thank you. And I'm not seeing any other questions, so I'm just closing this session to start the other stream.
Right.
Thank you.
By the way, feel free to open GitHub issues and go through those practices. I'm more than happy to help your questions on Mattermost or on GitHub, whichever you prefer, all the time, even next week or so. All right.
Perfect. See you around.
Thank you so much. See you. Bye-bye.
Bye.
Okay, hello everyone. My name's Sam. Welcome to the OHBM Brainhack 2020. This is a train track session on BIDS and BIDS apps. I'll start by saying unequivocally that Black Lives Matter, and that one of the most important things we can be doing right now is figuring out how to act in solidarity with and provide material support to the Black communities and anti-fascists that are currently struggling against white supremacy and state-sanctioned violence from the police. So if you spend the next hour doing that instead of listening to this talk, that will be time well spent. In terms of the presentation, I'm used to giving sort of conversational interactive talks. I'm not an expert in kind of pre-recording a talk like this, so I apologize for that. I'm going to keep it kind of informal. So like I said, this talk is about BIDS and BIDS apps, called The Benefits of BIDS, Data Standardization and Automated Processing for Neuroimaging Research. Now, I am not the sort of creator of BIDS. I'm not even really a contributor to BIDS. I am just sort of acting as a cheerleader here because I think that it is a hugely important step forward for our field, and we should all kind of work to increase the adoption of this. So with that said, I will first of all thank the many contributors to BIDS. BIDS is a very community-driven project. And you'll see here in many places in my slides, things that are this color blue like this are actually clickable links So if you click here, this is going to bring up the actual contributors list from the bid specification GitHub repo. As you can see, many people here. I don't have time to go through all of these people, but it's a lot of people from Russ Poldrak's lab, Chris Gordolewski, Stefan Appelhoff, Franklin Feingold, Tion Brooks, Chris Markovich, and so forth. What is BIDS? BIDS is the brain imaging data structure. So BIDS is a standard for organizing neuroimaging data that facilitates reuse and automated processing. And I'm going to unpack these terms, reuse and automated processing, as we go here. The BIDS standard specifies machine-readable directory structures, file names, file formats, and metadata. Machine-readable is is the keyword here, and this rich metadata is going to be very important for our purposes later on. BIDS is a consensus-based, community-driven project, and it capitalizes on existing conventions, existing software tools, and things like that. We're not trying to reinvent the wheel here. And there's a big emphasis on simplicity, readability, and accessibility. Something like this won't work unless it's easy to use and widely adopted. And so you have this kind of balancing act between creating something that is both machine readable and human readable. And BIDS really developed out of the OpenFMRI data sharing portal and repository that has evolved into the Open Neuro data repository. And when you start to share data like this, you begin to see just the importance of creating a standard of basically all of us speaking the same language when it comes to the data that we're trying to share and analyze. And just a little extra credit here. Pointing towards the FAIR principles, and this is a kind of ideal put forward for data sharing and reproducibility and things like this, saying that these data like this should be findable, accessible, interoperable, and reusable. And I think that BIDS actually takes us quite a long way in this direction, living up to the FAIR principles. One more thing that I'll point out here is that all of the little references that I have in the corner here are also clickable links that will take you, that have a DOI, will take you to these papers if you want to read further about any particular topic here. What's the point of all of this? I've spent some time of my life kind of trying to convince other people to switch to BIDS. There's often a lot of friction or pushback or things like this. The way that I like to start this, start that process is by asking, have you ever actually tried to reanalyze someone else's data? It's extremely challenging, and I'll go ahead and say, even trying to reanalyze your own data, from a year ago, from 5 years ago, can be very difficult. I know that I have data sets from, that I collected in 2015 or something like that. I want to go back and reanalyze that data set. It's basically like starting from scratch. I have to figure out what kind of crazy heuristic I used to organize the files. What was the input to output to this and the output of this script? Again, it's sort of like relearning whatever idiosyncratic language you were thinking at the time. And one of the main goals of coming to this shared language in terms of data is feeling confident in the data, in other people's data, and using other people's data, being able to trust other people's data, not having to email them constantly asking, like, why is this named this, or which one of these is the right one, or why is this organized in this particular way. The data set should basically be the metadata, right? The data set should basically be self-explanatory, should speak for itself, kind of like live on its own outside of the purview of the data generators or the initial authors. So the initial BIDS paper came out in 2016, and at that time they were saying, to date, in 2016, there has been no consensus about how to organize and share neuroimaging data, leading researchers, even those working within the same lab, to arrange their data in different and idiosyncratic ways. Lack of consensus leads to misunderstanding and time wasted on rearranging data or rewriting scripts that expect particular file formats and organization, as well as a possible cause of errors. That's the kind of problem that we're trying to solve here with BIDS. I want to focus for a second on this issue of data sharing. Data sharing is exceptionally important. Public, well-curated data sets have been tremendously beneficial. Think of fields like machine learning, where you have things like ImageNet and MNIST and COCO. These things not only do these things serve like a really important didactic role in like understanding how to analyze particular data sets or something like that, but these fields tend to, when you have a really good benchmark data set, the field is able to kind of like run up against this data set and build models and test models and compare models. And that's when you see these really kind of big acceleration moments until they completely exhaust that data set. And now it's time for the next really big, important data set. And I think we'll see this, we're seeing it already, but we'll see it even more in neuroimaging as data sharing and big sort of consortia become the standard. And I just wanted to point to a statistic from Michael Millam's group suggesting that publicly shared fMRI data sets from the INDIE consortia have saved an estimated $1.7 billion in data generation costs, right? And this is a real humanitarian kind of issue because that's people's tax dollars that would otherwise have gone into generating what is oftentimes redundant data. And that estimate doesn't even include these huge data sets like HCP, all of the things on OpenNeuro, the ABCD data set, or the UK Biobank, right? So the societal benefits of data sharing are huge. Automated processing is also a really important thing. And there's a recent Nature paper on this really driving this point home that neuroimaging analysis is very complex and also very flexible, right? It's a multi-stage process with a variety of kind of like a branching paths, a variety of possible analysis choices at each stage with these researcher degrees of freedom. And putting together a machine-readable standard for data organization like BIDS with this kind of rich metadata allows us to build these kind of automated processing tools. And this is important because it minimizes all the kind of like manual intervention and the way people like will gear a processing pipeline just for the sort of like experiments they typically do or their lab typically does. And the way these tools are made, the way these BIDS apps are made, is that they also maximize the kind of reproducible execution, reproducibility via containerization and moving towards better content tracking as well. And again, we'll get to that more later. Okay, so the initial BIDS paper came out in Scientific Data in 2016 from Chris Gordelewski. But things have, the ball has kept rolling since then. The community has kept expanding the BIDS ecosystem. So in 2018, we have the MEG BIDS standard. The MEG BIDS extension was sort of ratified, let's say. And following that, we have the EEG BIDS and the intracranial or ECOG BIDS data structures that have been finalized and published as well. So you can see that the ecosystem is expanding, and we'll talk more about that later. I am really most familiar with the fMRI literature and BIDS in the context of fMRI. So for this session, I'm mostly going to be talking about the initial 2016 BIDS format for fMRI data. But most of the things that you sort of learn from, thinking about BIDS in terms of fMRI are similarly applicable to other modalities. So when you start working with BIDS, you'll often find yourself, whether you're trying to convert a pre-existing data set to BIDS, or you're trying to start an analysis on a data set that's already in BIDS, one of the places that you'll often find yourself is the BIDS website here. And this is basically where you'll want to go to navigate the BIDS specification and so forth. And there's a couple things that before we really get into the nitty-gritty of the specification, there's a couple things that I'll point out here. First of all is getting involved in BIDS. Like I said, BIDS is very community-driven, and any one of you could become a contributor to BIDS in the next couple days over the course of this hackathon. You can be sure that there will be hackathon projects having to do with BIDS and BIDS apps over the next day or two. Some easy ways to sort of start easing yourself into this. I encourage everyone to check out Neurostars. Neurostars is sort of like a Stack Overflow kind of thing for neuroscientists, INCF funded question and answer forum. You can check out the BIDS tag there. Again, these are links that you can click on. And You can also check out the BIDS GitHub repository. You can raise an issue there if you have questions, or fork it, start making your own modifications, whatever you want to do. But I would really check out the BIDS code of conduct as well. And then, I had mentioned MEG bids, EEG bids, IEEG bids. These kinds of extensions to the BIDS ecosystem start in this form of what are called BIDS extension proposals, or BEPs. And so this is a community-driven model for expanding the BIDS ecosystem. There's a pretty detailed set of guidelines for how this is, for how the community, how the BIDS people expect this to be done. Here, I just want to point, I'm not going to go into detail about that. I'm just going to point out here that there are at least like 20 BIDS extension proposals that are currently under development. And these are just Google Docs, right? You can go look at this Google Doc, you can make suggestions and so forth, try to understand what the current sort of, what people are thinking the way this should work is, right? And if you have some input, you can supply it there. They're doing this for different neuroimaging modalities like CT and PET and NIRS, for different types of derivatives, your functional derivatives, structural derivatives, diffusion derivatives, and for different components of the software ecosystem like statistical models and image transformations and provenance, execution, things like that. So I really recommend checking that out under the Get Involved tab here. I'll also point for a moment to the governance tab here. I keep emphasizing this community-driven development. The way BIDS works is you have a steering committee, you have working groups, interest groups, all of which are democratically elected by folks that are involved in BIDS. And I'll just highlight, this is sort of rehashing things that I've already said, but I want to keep highlighting the kind of central tenets of how BIDS, we want BIDS to work, which is we want to minimize complexity and we want to facilitate adoption. We want to reuse existing methods and technologies wherever possible, not reinventing the wheel. And this is really important. We want to try to tackle 80% of the most commonly used neuroimaging data, derivatives, and models. Trying to get 100% is basically impossible. You can't cover everything. So you want to try to figure out where that, the center of mass is for most of the people that are using these kinds of tools, and shoot for that. And adoption by the global neuroimaging community is the only way that this really ends up working in the long run, right? And so trying to really cast a wide net, be as inclusive as possible, and bring in input from everywhere that we can. To try to pin down exactly how we want the BIDS specification to work. Okay, so getting down to business here with the specification itself. Again, you can follow along on the website if you'd like to. I'm going to kind of just walk through things, but the BIDS specification itself is what's going to take us from whatever, the DICOMs that our scanner is printing out into this nice, both human readable and machine readable format on the other side here. I'll walk through a schematic example of this. I just created this by hand of what this BID structure would look like. Keep in mind that there's a whole GitHub repo of like lightweight these are example BIDS data sets that don't actually have the heavy data in them. It's really just the structure of the data, but this is great if you want to sort of prototype tools that work with BIDS and so forth. So I'd recommend checking out the BIDS examples repo on GitHub. Okay, so what do we have here in this schematic example? The very top level, where I'm just calling it data set here, this is your kind of, this is your top level BIDS directory, okay? Within that, you're going to, what's highlighted in yellow here are some kind of top level files, metadata, and this includes this participants.tsv file, which I'll show you in a little bit, tab separated table. It's got participant labels and demographics, condition information, and so forth. A data set description that's in this JSON format, that's kind of like a key value format that I'll show you later on as well. Then some other files like a README that just gives you kind of verbal explanation of what's going on with this data set, and a change log so that you can keep up with what version of the data set you're currently working on and how it has kind of evolved over time. Next, you'll see I have these subject directories here, sub 01, sub 02, sub 03. this is where the real kind of data is going to, the raw neuroimaging data is going to live. In the fMRI case, this is going to be your nifty images and so forth. So this is going to be your subject-specific anatomical and functional nifty images. For the most part, these nifty images are going to be accompanied by what we're calling JSON sidecar files. I'll show you one later on, but these capture the metadata that's not, like, important metadata that's not necessarily captured in like the nifty image itself, like acquisition parameters and things like that. In this example, I also have an events.tsv file. That's really important for, you know, it's hard to analyze a neuroimaging data set if you don't know what was happening over the course of the scan, right? So I'll show you an example of that, but it's really just capturing this kind of like event or block or stimulus task structure that's going on in your fMRI experiment. And then finally, you have some more kind of loosely structured directories for code, your analysis code, for derivatives of your analyses, like from things like from MRI QC and fMRI prep, which we'll talk more about later, and for stimuli as well, if it's possible to provide stimuli. Okay, so that's the schematic example. Let's try like a real life example here. And this is going to be, this is Open Neuro dataset 000233. This is one of my shared data sets, so I'm sort of very familiar with the structure of it. And you can click here if you want to navigate to Open Neuro where this data set lives. Okay, and this little summary here is just telling you, okay, who owns this data set, how many subjects, 12 subjects in this data set, it's about 4 gigabytes. There are 2 different tasks and some different types of files in here. This is actually telling us, this is a little glance at the kind of directory structure that we have here. So you can see a lot of things recapitulated here from the schematic example. You see the change log, the dataset description, the participants file, and so forth. So let's have a look at a couple of these. So if we open up this changes, file, I actually cut off a little bit here because I screwed up this changes file at one point. But you can see the kind of release history here, the version history, right? So you see the initial release in 2017, then at some point I added more derivatives and code, and then I wrote a paper about it, and then I eventually added the shared stimulators. You get some history of the data set here. This is not the most sophisticated way to track the provenance of this data set. These are things that I'm just writing into here. And I'll mention in passing later on a more sophisticated way that we can do content tracking with Data Lab. So that's your changes file. The README in this data set just has a little description and a couple caveats that came up during data collection. Won't dwell on that. This is what the participants TSV file looks like for this data set. We have these sort of long subject IDs here, but that's not really important. You have this column structure where your first column is participant ID, your second column is age, you have a sex column here, and group. In this case, these were all just sort of typical subjects with no between group manipulation going on, or between subject manipulation going on here. So I just have them labeled as controls. Keep in mind that this is like a relatively minimal example. You can fill this out a lot more, right? If you have a lot of other interesting kind of subject demographics, you can fill those out into this participants TSV. If you want to get creative with that, all that the BIDS asks of you is that you also include a participants JSON file that basically tells us what do these column names actually mean. I don't have that in this particular example, but that's sort of best practices. Let's check out the dataset description file here. Yeah, just this is this kind of JSON format, right? If you're familiar with Python, it's very similar to the way that a Python dictionary is set up, where in the curly brackets here you have a key. The first key here is acknowledgements, and that key is colon attached to a particular value, which is the acknowledgements section for this data set. You have another key that's like the authors, which has a list of the authors, and so forth. This is actually, on Open Neuro, it's reading this data set description to populate the to render the web page for the data set with the correct information. Okay, so that's a lot of this kind of top level metadata here. We can dig a little bit further in. Let's skip down to subject RID 00001 here. And so inside this subject's directory, and again, this is not derivatives or anything like that. This is just the raw nifty images for this subject. We have a split between anatomical and functional data, so anat and func. If you were to have field maps or diffusion or all sorts of other things like that, these would be in separate folders here, but here we just have anatomicals and functionals. So let's have a look inside the anatomical directory here. There's some strange things in here that I wouldn't worry about, but the main thing to keep in mind here is we just have this anatomical file sub RID 00001 underscore T1, and it's a gzip nifty. You'll notice these file names also sort of share this key value kind of structure here. So each key value pair is separated by an underscore, and the key and the value are linked by a hyphen here. So sub is a key for subject, and this subject value is RID 00001. And this file ends in this kind of suffix that is T1W, just indicating this is a T1 weighted structural image. Okay. Have a look at the functional directory here. You see a lot of similar things, right? So here's your functional nifty image. Again, you can see this kind of key value structure in the file name here. You have sub RID 00001. You have a task key that is, in this case, has the BEH or behavior value. You have a run key with run1 is the value, and then it ends with this bold suffix. Here you can also see these JSON sidecar here. That's just the same exact file name, but with .json instead of .nifty.gz, and you have the events.tsv accompanying this file as well. So let's look for 1 second at this JSON, right? So this is a key value dictionary here, and it just has a lot of important acquisition parameters and things like that, right? So we have the repetition time or the TR here, the task name for this particular acquisition, the echo time or TE, the flip angle, the slice timing, and so forth, right? This is all the information that in an ideal world you would be reporting in the methods section, you know, following the OHBM's COBITIS guidelines or something like this. You want to put all of that into your paper, but it should also live alongside with the data set so that it can be machine readable as well. We'll also have a look at the events.tsv for this acquisition. And you'll see this was a kind of, this was like a pretty rapid event-related design with, you know, so at 12 seconds, the first stimulus appeared and it was 2 seconds long. And the trial type for the stimulus was an ungulate, some kind of like a deer or something like that running. And I have the condition information here, like the taxonomy is ungulate, the behavior is running. The task that they're doing for this entire run is behavior. This is not a repetition trial. A repetition trial does occur later on. It's a behavior repetition, and you can see that the subject correctly responded, or the subject responded to this with this particular response time. So this is what allows you to really analyze this data set. Otherwise, it's just a sort of time series of fMRI data with no real structure to it. Here you have all of the events. This is what you would use to build your design matrix for your GLM or something like that, or to decide what stimuli, or what patterns are going to correspond to what stimulus for your classifier and so forth. Okay. I'll touch on the last, there's at the top level, there's also these other folders, derivatives, code, stimuli, things like that. These are not strictly necessary, but some data sets will have them. So in this particular data set, we do have some MRIQC derivatives. So you see this MRIQC directory that's living in the derivatives directory. for this data set, we included some code along with it, right? So we have a Python script here that compiles our events. We have a Python script that compiles our stimuli. We have a Python script that prepares the anatomy, like defacing these images and so forth. And then with this particular data set, we also provided stimuli. For this data set, these stimuli are actually like silent clips, right? So here's, bird eating number 2, which is this hummingbird at a flower. And here is bird, here we go. Bird fighting number 2, which is these vultures fighting. Including the stimuli along with the data set is not always possible due to copyright issues and things like that. But particularly in the context of naturalistic data sets, movies and stories and things like that, it can be really important. It can be really helpful to share the stimuli as well, because those stimuli are so rich and there's so many kind of features that you can extract from the stimulus, so many models that you can build based on a naturalistic stimulus. And if you don't have the stimulus, it's hard to do much. Okay, so that's our example data set. I'm going to switch gears for a second here and talk about converting data to BIDs. A lot of people, I already collected an fMRI data set. I didn't format it according to BIDs. Now I have to go share my data, because the journal demands it or the funders demand it. I have to go back and reformat the data according to BIDs. I'm not going to go into details about this. There are a bunch of tools out there that can help this process, like QDConv and DCM2Nix and PyBids. But yeah, this can be a kind of annoying process. I've converted a lot of my own data sets and other people's data sets to BIDs. And usually it just boils down to, okay, person X in the lab has their own idiosyncratic way of organizing data. I really just need to build some little script or heuristic that takes their idiosyncratic data structure and converts it to BIDs. And that's the worst kind of script to write, because once you get it working correctly, it's important to sort of do it programmatically and to keep track of what's going on, right? But once you get that script working directly, it's basically like a single-use script that's manually tailored to that particular data set. That is not ideal. That's the hard way. The easy way, however, is to use some kind of pre-specified naming convention when creating program cards on the scanner console. And this can allow you to do automated conversion to BIDs. This is not, I'm not sure that this is, that some kind of standard like this has been developed for all sorts of scanners. But for Siemens scanners, we have this repro-in heuristic. And this was created by Matteo Visconti di Oleggio Castello and Jarek Halchenko. And here you can see this just a little schematic here. Basically what you're doing is if you follow a certain structure in actually creating the program card on your scanner console computer, you can then feed that into a program that does conversion to BIDs like QDConv, and it can understand, okay, this is following the repro-in heuristic here, so I know how to convert all of this automatically to BIDs. And I cannot recommend this process enough. If you're using a Siemens scanner, I would, the next time you start collecting data for a study, I would try to start collecting data in this particular way. Jarek and Matteo set this up at Dartmouth, and at Dartmouth, data comes hot off the scanner. It is immediately version controlled with DataLad. It is immediately converted to BIDs. They can even run MRI-QC and things like that in an automated fashion right off the scanner. And that really helps people out, really facilitates data sharing as well. At Princeton here, I think the vast majority of people that are now scanning at Princeton are also using the repro-in convention and converting with and doing automatic BIDs conversion with QDConv. So the moral of the story here is that start thinking about sharing and standardization from the start. You will save yourself so much time and pain if you just sort of like do it right from the beginning. With sharing kind of like in mind, right? Because in most cases, you're going to have to share it anyway at some point, you know, based on the journal or the funding source and things like that. So best to kind of like take care of that as early as possible, so you don't get to this like way down the road, have to go back and change everything, and do my analyses still run now that I reformatted all the data and so forth. That's a nightmare. Try to start the standardization process as early as possible. Okay. One more important thing here is when you're converting data to bids, right? How do you know that you've done it correctly? How do you check your work, so to say? And so the bids validator is, and the bids validator is kind of a bids app in itself, right? But really what the bids validator is doing is it's a lightweight tool for ensuring that your data set is bids compliant. There's a browser-based version of this, but you can also do it locally with NPM or Docker, Python, etc. Again, if you click here, this will take you to the link where you can point the browser to your data set. Bear in mind that your data set is not ever being uploaded to the internet or anything like that, because that would presumably violate a lot of people's privacy and things like that, right? It is a browser-based application, but it is running client-side locally on your data. So that's how you check that your data, the data that you've converted is sort of BIDS compliant. I had foreshadowed this once or twice before, but anybody who does programming with Git and GitHub and things like this, you start to understand how critically important version control and content tracking and things like that are for both like keeping track of your own code and maintaining a sort of like provenance, like the history of what's happened to your code, and also distributing your code, like sharing your code on GitHub so you can have collaborators who are working on it, or you can package it nicely and distribute it. DataLad is, I would point you to DataLad as the sort of go-to tool for doing a similar thing to what Git does, but for data instead of just code, right? You can't upload a big data set to GitHub, of course. And so this is the kind of problem DataLad is designed to solve. And the way that DataLad basically uses something called Git Annex under the hood, which is going to be tracking the content and changes to your data set. And so you can, as you can see here, this is a kind of Git log for all of the changes that I made to a particular data set with DataLad. You can run code with DataLad such that it will track sort of the code that you ran and what the sort of input output of that code was. And DataLad also serves as a distribution for data sets. So DataLad, I think, is currently crawling some 240 terabytes of data that is hosted in all sorts of different places all over the world. So in that sense, DataLad is both kind of like a content tracking or version control system, and it's also like a data distribution in the same way as like a software distribution, in a similar way to a software distribution. Adina Wagner and Michael Hanka and Yarek Halchenko, some of the main DataLad people, they have, Adina in particular has put together this beautiful DataLad handbook, which is just one of the coolest things I've ever seen. I would really recommend checking that out for both a really kind of intuitive guide to learning DataLad, but also just like a very exhaustive, amazing resource as well. Okay, so that's BIDS in general. Now we're going to start talking about some BIDS apps. This is a PLOS computational biology paper from Chris Gorgolewski introducing BIDS apps, how the sort of philosophy behind them. And this paper also included, I mean, there's some, I don't know, there's many BIDS apps at this point for all sorts of different things. We're going to be focusing on two of them. But to kind of understand what a BIDS app is about, right? So the machine readable BIDS format enables this kind of automated processing via BIDS apps, right? And BIDS apps use containerization to facilitate portability and reproducibility. What is containerization, right? Containerization is a way of packaging software such that all of the dependencies and things like that are encapsulated in one single image. This is super important for reproducibility because you don't want, just using system-wide installations of software that are kind of, reaching into whatever, grabbing whatever environment variables, right? That really difficult to kind of reproduce software ecosystems that are set up like that, right? And so containerization kind of tries to tile this into like a tight container with, a version history and things like that. So, if I get this bids app from here, I'm 100% sure of what is sort of going on in this bids app when I run it. And even, ideally 10 years from now, I can grab the same version of that bids app and try to run it, and it should behave in the same way because it's ideally not using things from outside of the container in the analysis process. So the main containerization solutions that or technologies that we use are Docker and Singularity. And so you can think of like what goes into creating like a Docker image or a Singularity image is basically a little recipe that specifies the computational computing environment, what needs to be installed, where is it, what version, where does it get installed from, and things like that. It builds it up, okay? And then you have, that's what's represented here with these little bids apps that you have continuous integration for testing and things like this and validation. They live on Docker Hub. And then these Docker images, if you're just running it locally, you can just use Docker to run it, and it should be relatively robust to different sort of systems, OSs, environment variables, and so forth. And then if you're, people typically, you're not using Docker on a server because of certain ways Docker is set up. Singularity is the tool that provides the analogous service for multi-user servers. And I'm actually going to mostly give Singularity examples here because I'm not usually running things like locally because the data is just too big and my poor laptop can't handle that. I'm running something remotely on the institutional server. And when you're on the institutional server, it's going to be Singularity. Okay, so our first example bids app is going to be MRI QC, which is a automated sort of quality control package for bids formatted data. They have this initial PLOS One paper, and they also recently had a scientific data paper come out. One of the cool things about MRI QC is that when you run it, if you don't opt out, right, but when you run it, it's actually logging the kind of quality control metrics that it's digging up out of your data, such that we can eventually have a big sort of repository of these sorts of metrics, so we can know like what's good, what's bad, and so forth. So that's in the process of being aggregated. If you were to build a MRI QC Singularity image, it's basically as simple as this: Singularity build. This is the name of your Singularity image here. You're pulling it from Docker Hub. PullDrac Lab has a page on Docker Hub, getting the MRI QC in here. I'm specifying a particular version 0.15.2. Okay, I'm going to do a total sort of side thing here because I want to talk about another one of my data sets. This is totally self-serving advertisement here. But this is the data set that I'm going to use to show you examples of these bids derivatives from bids apps. This is the narratives data set that is currently on OpenNeuro, but I'm still in the process of kind of expanding this particular data set. This is DS002345. There's over 300 subjects. We should have another batch getting us up to 345 subjects coming relatively soon. There's something like 20 plus different audio-only stories that participants listen to with this data set, and we provide the stimuli as well. So anybody who's interested in natural language processing and things like that, semantic representation and so forth, events representation, I think this will be a very useful and helpful data set of naturalistic story listening. The other thing that's nice about this is it's a bigger data set, right? Like this is a much sort of heftier data set to kind of show you the capabilities of this. And what I find completely amazing, right, is that you can point something like MRIQC to this directory that contains all of these subjects and just say go, and it will, unless you screwed up the command somehow, right, it can just understand how to do quality control on this data set with essentially no further input, right? You just say MRIQC subject 1 for me, and it reads all of the metadata out of those JSON files. It decides whether it needs to do this or that kind of processing step and gives you the QC results. So yeah, there's a bunch of, I had sort of mentioned this before, there's a bunch of stories in here, lots of subjects, something like 150 hours worth of fMRI data. So I recommend checking it out if you're into that kind of thing. So what is the MRIQC output for this kind of data set? And here is the example that I'll show you. Now, this image here is also a link. And if you click this link, I have set up a GitHub repo that has, you know, the minimal example versions of these QC outputs that you can look up. If you click this link, it's actually going to take you to the HTML kind of like preview of this. But what's cool about that, you can't see that here, but is if you hover over these points in that, if you actually open this HTML file, you can hover over these points, see which runs they are, see what various different things mean here. So it's kind of like an interactive plot. But in general, this is just the group sort of structural report for all of these 300 subjects. I won't really go into detail with this. I also have as an example here the group bold report, so for the functional data. And you can see some kind of interesting things here. So for example, if you look at like the TSNR here, it looks like we have a median TSNR around 50. I don't know if that's good or bad. You can look at the frame-wise displacements that we have here. Again, hard to say whether that's good or bad for you. You can look at the smoothness of the images that we're working with here. The SNR of these images, one thing that's kind of funny about the SNR of these images is these high SNR ones are collected, you know, from an older scanner using sort of older style acquisition parameters. These ones with lower SNR are, you know, newer scanner, fancier acquisition, you know, multi-slice acquisition with smaller voxels and so forth. There's a ton of information in here. All of this information is also kind of represented in TSV files in like tabular format, right? So you can really do whatever kind of analysis. This is just their kind of like built-in visualization of this, but you can do whatever sorts of analyses that you want here. So this provides you a lot of kind of quality control metrics. And I am not exaggerating when I say that it is like one line of code where you just point to the bids directory and say, give me subject 1 or give me the group or something like that. And it does all of this and generates that for you just based on the bids metadata. Even more advanced is the second bids app that we'll be talking about here, which is fMRI Prep. And fMRI Prep is a pre-processing pipeline for functional fMRI data. This is functional MRI data. This is also from Oscar Esteban. And they also have a very recent, hot off the presses, Nature Protocols paper about analyzing task-based functional MRI data that were pre-processed with fMRI Prep. These images are links. You can click on them to get the DOI, which will take you to the papers to read. Oops, I have a typo here. This should be getting the fMRI Prep Singularity image. But so similar to before, the way that I would do this Singularity build, get an fMRI Prep image from Docker Hub, Poldrack Lab, specify whatever version you want. If you don't specify a version, it's going to give you the latest version. That's fine too. I'm just being a little extra verbose here. Okay, so I'll use fMRI Prep as our example of kind of like digging a little bit deeper into how a bids app, you know, what the kind of like inputs to a bids app are, and how you would run this with Singularity. So the kind of quoting from the paper here, fMRI prep is a functional magnetic resonance imaging data processing pipeline that is designed to provide an easily accessible, state-of-the-art interface that is robust to variations in scan acquisition protocols and that requires minimal user input while providing easily interpretable and comprehensive error and output reporting. fMRI prep, you can think of it as fMRI prep will take in your raw nifty images and it will do things like align, do volume correction to align each volume that's acquired over time in the functional images, align those to the T1 image and potentially do things like slice timing correction, potentially do things like anatomical segmentation into CSF and white matter, and also full-on free surfer reconstruction and surface projection and things like that. And ultimately, it's going to push your data into some output space, like MNI space or FS average surface space or something like this. There's basically two main outputs that you get. There's all of this sort of visual error reporting and QC and things like that. But in addition to that, the two kind of main outputs that you get from running fMRI prep are a bunch of confound variables that were extracted over the course of pre-processing. So that's things like head motion and derivatives of head motion and frame-wise displacement and things like anatomical comp core and principal component time series from your CSF and white matter and so forth, global signal and motion outliers. And so it gives you a giant table that has all of these things, all of these confound variables in it, so that when you go on to your GLM or you're doing resting state or something like that, you have this whole list of possible confound regressors that you can choose from to try to regress out or model in your data. And then in addition to that, it provides the actual data themselves in whatever output space or spaces that you specified. Okay, so what is the simplest kind of fMRI prep command look like? This syntax here is really the case for all BIDS apps, right? Which is that you have this, you have like the initial fMRI prep program that you're going to be running, or the executable, or what's really in this case going to be like a Docker Singularity image. You have in green here the BIDS folder, like the input directory. And you have in pink here where you want the output to end up. Typically, I would be putting this inside derivatives inside my BIDS directory. So the output folder is going to be a subdirectory called derivatives or derivatives fMRI prep inside your top level BIDS directory. And then you need to specify either participant or group level analysis. And this will depend on the kind of BIDS app that you're using. In the context of fMRI prep, you're typically going to be doing, it's a participant level, within subjects analysis. MRI-QC is actually a little bit different, right? Typically you want to run MRI-QC on each of your subjects at the participant level. And then after you've done that, you can run MRI-QC again, specifying group, which will aggregate across all of those individual subject runs of MRI-QC and give you that group plot like the ones that I showed you. So this looks relatively simple, but it does get a little more complicated when we take into account Singularity and things like this for running on a server. So here is my example of a kind of fully functioning Singularity command to run fMRI prep. So the purple here is really just calling Singularity. We're doing Singularity run here. We're using this clean env flag because we don't want Singularity to be sucking in any outside environment variables and things like that we don't really are not keeping track of, things that we don't know about. So we use clean env. Here I'm binding whatever my BIDS folder is outside of the Singularity image, and I'm just calling it data inside the Singularity image. And then I'm calling Singularity on where my fMRI prep Singularity image lives, which is here. I'm just sort of, it's my home directory of sorts where I have my fMRI prep version 20.1.0 Singularity image. So I tell Singularity, take in these flags, run this fMRI prep Singularity image. And then everything that's following that is a bunch of fMRI prep arguments, okay? The ones in green here are the keyword arguments for fMRI prep. So here I'm specifying a participant label, just run participant or sub 001. I'm going to use 8 cores, and I want outputs in T1W, FS average 6, and MNI 152 nonlinear 2009 C asymmetric spaces. One thing that's nice about fMRI prep is however many of these output spaces you list, it will just give you, it will run and give you all of them, right? So you will get outputs in all of these different spaces. You can ask for 1 or you can ask for half a dozen, whatever suits your analysis. I have a couple other things here that are not that important. Here I'm using the sort of field map less field map correction with this use SYN susceptibility distortion correction. I'm pointing to a FreeSurfer, FreeSurfer license file. I'm specifying where I want the work directory to be. And keep in mind that for fMRI prep, the work directories can get pretty large. We're talking many gigabytes. That's something, you want to keep those while you're still sort of like, working on analysis and potentially rerunning fMRI prep or something like that. But down the road, you'll likely want to get rid of those work directories so they're not taking up so much space. And then finally, in this big command, we get just those positional arguments, which is the input data set, the BIDS data set. And here again, this is the name of the data set as I have bound it inside the singularity image. So it's called data because I called it data. We're saying, put the outputs in data/derivatives and do this at the participant level. So that's your example of an fMRI prep command. And I'll just spend a minute here before we wrap up to look at what these fMRI prep outputs can be. And again, this is on GitHub, so you can navigate to this as well. I'll have the GitHub link at the end of the, you'll be able to find the GitHub link as well. So when I click on this, this is going to take me to a HTML rendering of the fMRI prep outputs. And so I can see here at the top, I have a summary. I have 1 structural image that's T1 weighted. I have 3 functional scans, 2 PyMan runs, and 2 tunnel runs. These are from the narratives data collection. So these are both story listening data sets. And here I'm asking, in this particular case, I'm asking for output spaces as standard spaces in FS average and this one, the sort of newest, fanciest MNI 152, and then an older MNI 152 that's sort of common for FSL people. Also some other output spaces. It's telling me here that FreeSurfer, fMRI prep also ran FreeSurfer in the process. So I have this input anatomical image, and here's all of the kind of cool QC and visualization that I get with fMRI prep. One of the main concerns that people have when they look at fMRI prep is it's like, oh, well, if it doesn't require manual intervention, then how do I know what it's doing? It's like a black box or something like this, right? And that is not the right way to think about it. First of all that kind of manual intervention introduces all sorts of errors and allows you to kind of like weirdly fine-tune your analysis pipeline in ways that maybe you shouldn't. fMRI prep does that automatically based on sort of these community driven standards and heuristics. And fMRI prep is what we call a glass box, right? Which is that all of the code fMRI prep has exceptionally detailed documentation. All of the code, you can introspect any of the code, all of the errors are tracked. And basically at every stage of the analysis, you can see sort of what the inputs and outputs were. You can see the sort of, graph structure of the workflow, and you get all of these beautiful visualizations of what's going on at each stage here. So this first one here is tissue segmentation of the anatomical file. Some of these don't render well. based on the GitHub way that I did this. Here you can see the surface reconstruction, where you have like the red line outlining the peel surface and the blue line outlining the surface of the white matter. Everything in between there is what will end up as your free surface. This one looks pretty good. These data are, I don't know, 5-7 years old. So this is not too bad, I would say. Here we get into the functional outputs. So again, you have a bunch of details here, like the TR for this was 1.5 seconds, phase encoding direction was anterior to posterior. Here I did the field mapless SYN-based correction. And here is this giant list of all of the confound variables that were created by fMRI prep over the course of pre-processing. Again, some of these images, some of the moving images don't show up in the way that I have this rendered right now. But you can see how this is, we're going to segment CSF and white CSF here to get a mask that we're going to use to create the AComp core regressors and so forth. Variance explained by the AComp core regressors. And then a really nice summary visualization here of some important quality metrics like global signal and frame-wise displacement and stuff like this. You can see, that this subject towards the end of this run had like a pretty nasty, jerk of their head. And this is very evident in the carpet plot here. We can see it's not too bad, but then there's a big here towards the end. fMRI prep provides you this correlation matrix amongst all of the nuisance variables, and then we go into this for the other runs. Okay, so you can sort of explore that to your heart's content. That'll be enough for us, I think. And so I'm going to wrap this up here by, again, just trying to re-emphasize that, if we want a more collaborative, scalable neuroimaging, we need data standardization. Data standardization is the linchpin for this kind of reproducible, scalable neuroimaging. And so BIDS, I think, is the top contender for this, and I think that's the way it's going to be. Community-driven standard for organizing neuroimaging data that facilitates sharing and automated pre-processing. BIDS apps are portable software containers that capitalize on BIDS format to reproducibly analyze data with minimal manual intervention. I have a couple links here at the end. This points to the GitHub repo where you can look at these outputs and things like that. There's a Zenodo, there's like a PDF of these slides in case that's useful. And there's all sorts of other resources out there for understanding BIDS. I didn't create this talk from scratch. I was just looking at other people who have given similar talks. So from the Center for Reproducibility folks and all these other BIDS presentations that are available on OSF. And then just to bring up that I am personally funded and giving this talk kind of on behalf of INCF and Repronym. So feel free, I put my email at the beginning of the slideshow, and I'll be on the Brainhack Mattermost. So feel free to contact me if you have questions or want to hack or things like this. I hope you got something out of that. Alrighty, thank you, bye-bye.
And we are live.
Yes.
Hello, everyone. So I think we had 2 people. Okay, as usual, I'm going to close everything in the background because otherwise my very short attention span will make sure that I have no idea what's going on. Good. Give me 2 seconds and then I will be completely here with you all.
Great.
Okie dokie. So we have 2 people for the unconferences. We have Hao and we have Cooper. Sort of sorry I had to close that thing a bit early because, well, we're running late. So we're trying to sort of catch up on schedule.
So I'm
We
in my
are,
team.
what, 15 minutes behind schedule, I think. Yes. Okay, so let's do this. Selim, should I let you just invite, I guess, Hao or Cooper on stage, whoever
I
wants to
did.
go first? Okay,
I-
cool, brilliant. Let's do this.
Hello.
Hello, hello.
Hello.
All right.
How do you want to do this? You want slides or are you just...
I have no slides. I just,
Cool.
because it's on conference. Why would you need slides?
I don't know. Some people should not have slides for a conference. We're like, who the, what, how? Yeah, so come on, let's go. Let's do this.
So we have a lot of open access data sets and free data sets out there now. And we are entering an age of, we are probably not going to analyze the things we collected on our own. We're going to analyze other people's data. And every project has a different standard for documenting things to some extent. And I think for the FMI part, it is amazing. We have bits and all that standardization for your analyses pipelines, and things don't really go very wrong with the FMI part. But on the other side, we have phenotype data with behavioral, and recently I started with physiology, and all that kind of things are just a bit chaotic. And especially when you're dealing with human participants, they can drop out of like a testing session and you will have missing data. So how do you handle those missing cases becomes a very important topic. However, I work on this kind of things for the whole time of my PhD, and I realized there's no guidelines on how you handle these kind of missing data. And I have talked to friends working as data scientists, or he likes to call himself a data engineer in the industry, because he handles like the practical issue of cleaning data and data warehousing, and make people who are good at doing analyses to do the analyses. So our consensus was there's really no guidelines on the market on how you're going to go about this. And the only way to learn it right now seems to be just look at a lot of data set. So I have a few tips on how to do this. And I do wonder if other people have better tips. So if we can continue this discussion as some form of like a document, we can start drafting something. People are interested in that. I am totally on board. So yeah, I'm going to share my 2 tips of cleaning phenotype data. So typically, when you're looking at phenotype data, if you have a huge CSV file, and each row is a participant, and each column is one entry of that behavioral data, you can look at the data either horizontally or vertically. So if you look at data horizontally, you're looking at how many data points does this participant have. And if it's under a certain percentage, we probably will just drop that participant. And right now, a lot of people's rule of thumb is, no, there's not actually no rule of thumb for participants from what I know. But if we look at them vertically, you say, okay, so we collect fluid intelligence, we collect their anxiety score, something like that. And for each row, if you have like missing data above 30%, then people might say you don't have enough, you might want to drop this variable. Because when you have these missing data, you are going to replace those missing parts with, for example, mean or median, or the most frequently occurring number in that variable. if you have more than 30% of data missing, this implies you might not have good exemplar for the population on that variable. Therefore, an imputation of using mean or median will be off. So those are the rule of thumb I use. Unfortunately, there's still a lot of variation on different kinds of variables. So if you have any tips and you also struggle with the same thing like me, please come reach out to me and have a chat.
Actually,
yes.
Have you heard of the DS Psych project?
Yes, no.
So it's pretty much some people from more the psychology background. They're trying to, I think, massively inspired by the BIDS thing. They're trying to come up with a standard data structure organization for psychological data in general, to have its own validator and things like this. So, and I think that next week they are having a hackathon at SIPS about that. So yeah, I'll try to link you up with some of the people there. Maybe I think they would be interested in this, and I think that I might be mistaken, but I think Tal Yarkoni is sort of circulating like around that, or gravitating around that project as well. So he might actually know way more than I do. I wouldn't be surprised that we have a couple of BIDS people involved in this as well. So yeah, I think that yeah, I'll try to sort of point you towards this. From the top of my head here, I don't have anything else, but maybe I think they'll be interested in hearing more from this, because if they want to have like sort of validator for the structure, I think that would be the kind of warning that you want to have in a validator, right? It's like, hey, you're missing a lot of data points here. So yeah, I don't know, but I think they'll be interested. They might have some input on this. Yes, Ishila has posted the link. That's the one. Yes, exactly, that's the one. I'm not sure how far this project has gone since last time I checked, but I know that there were some people working on it. So you might want to get in touch with them.
That's fantastic. Yeah, thank you very much.
No problem. But I guess all the people might have ideas, so please.
Yes, that's the purpose of a conference. If I don't come here to talk, I won't learn that.
Exactly. That's the whole point of it. Cool.
Awesome. Yes.
So are we moving on? See you later, Hao. Thank you for everything.
Thank you.
And then Cooper, are you ready to come on stage? I guess we can just invite him, and then if he refuses. I think that he was waiting for Daniele to be around, and I can see that Daniele is here. So I guess we can start.
I invited both.
Oh, you invited both of them? Cool. Okay, let's do that.
Hey.
Hi, Cooper.
Not long ago that we were in the same spot.
Exactly. We keep bumping into each other, Cooper, somehow.
It's the way of the internet. So I wanted to give everyone an introduction to a project that I've been developing the last couple of years. I launched it at SIPS last year, and I realized I haven't actually introduced the Cogneuro or Neuro community to it yet. The project is called Free Our Knowledge, and it's based on a simple premise. The premise is that basically you can think of academia like a giant collective action problem. There's a place that we want to get to, let's call it open science, and there's where we are right now. And unfortunately, the problem with the system is that we're so kind of trapped by the reward structures of our institutions and our sort of cultural norms that it can be really difficult for us to move forward as a herd and adopt the behaviors that we know would be good for us and our community. And to me, the really clear example of this is publishing, because I mean, the fact that we still have papers and we're using journals like these pre-internet terms shows just how little progress that we've made since the internet was developed. And I think the critical reason for that is that we've built these journal brands up to be these powerful brands that they are today. And what that means is that new journals that come into the space that might be more in our interests and more supportive of the community can struggle to gain a foothold and get the kind of submissions that they really deserve. And that's because they're coming in at the bottom of the impact game. Like a new journal doesn't really have a reputation, and because we know we're rewarded by the reputation of the journals we publish in, it might not attract as many like high quality articles that it might otherwise if it had that reputation of the high impact journals. So what Free Our Knowledge is trying to do is create collective action towards achieving our open science goals. And so, like, if you think about the publishing industry, one way this might work is if you took the extreme example and say everybody in neuroscience decided to support only open access and free to publish journals, then those journals would be boosted in prestige and begin to attract high quality contributions of their own accord. So this is the basic premise behind Free Our Knowledge. You can kind of think of it as the Kickstarter for academic behaviors. Kickstarter solves a kind of economic problem, getting people to put capital towards building a new product. What Free Our Knowledge is trying to do is collect behavioral capital towards new cultural norms that we want to see happen. So I might just try and share my screen.
Yeah, I will get off stage so you can share.
Okay, yeah. I tried this morning and it didn't really work, so we'll see if this works.
Once you share, I'll set the focus on your screen. Yeah.
Is that working?
Yeah, it's working.
Okay, so this is the platform that we've built. You can see, basically, if you scroll down, it's just got a bit of a blurb, and then it's got some campaigns that we're running. Now, these are all based around open access right now, so you can pledge to exclusively support journals that comply with these criteria. But the key point I want to make is that although I originally designed this project to be around publishing, I've realized that actually this whole concept can work for any area of open science, really. And so this last box is the one I want you to pay attention to. Like, the idea here is that basically anyone could propose a campaign that is of interest to them. So this could be something like posting your first preprint, and you might ask, say, 100 of your colleagues to post a preprint as well. Or it might be pre-registering a study, or say you're interested in collecting data for a meta-analysis. Then you could post a campaign asking colleagues to share their data to an open repository, and then collaborate with them to produce the study. So the idea is that different sectors of the community create their own campaigns and then hopefully drive those to the point where they get to a critical mass of support. And then once that critical mass of support is met, everyone who's signed that campaign is listed on the website and then is asked to carry out the pledge that they've made. So that's the basic premise. The key point is that until that critical mass is met, no one's asked to do anything. So I'd have to log on to show you that, but you basically sign a pledge and your name is logged in the register. It's shown up as a number in the counter. You can show your name if you want, but it's optional anonymity. And you only ever have to act on that pledge if and when the critical mass is met. And at that point, the idea is that then you've got the protection of your colleagues, and you can all take on the behavior together. So that's the platform. I've been thinking about different campaigns that we could run, and one thing that really struck me is that there was this amazing journal that was created a couple of years ago called Neurons, Behavior, Data Analysis and Theory. And I'm not sure if Daniela is going to be able to introduce that journal here. I'll just end my screen sharing. Daniela, are you there?
Yes, I am. Yes.
You are not visible.
Yes, now I am. Good. So yeah, thanks for reaching out to me and for the shout out to the journal. It's indeed an initiative we are very proud of, and we completely share the our opinion on what may prevent for the moment to really kick off. Take off, despite being such an obvious win-win situation indeed. So what we hope to do is to reach out to as much people as possible and try to convince them that this is eventually the way to go. And one way we are doing it is by trying to recruit reviewers. So if you go here to the web page of the journal, which I will share in the chat. Yeah, indeed, is that one. So from here, you can sign up as a reviewer. So there is a Google form that you can fill, but of course you can reach out to us. Then you can, whenever you have a paper, or some of your colleagues or someone you know has posted a preprint or is willing to post a preprint and doesn't know where to send it, they can get in touch with the editors. There is a really long list of editors, and there's really no problem in making it more inclusive. So the idea is to cover virtually everything in neuroscience. So if something is missing, please get in touch, and we accept any type of submission. So it can be a software paper, can be a data paper, or a regular research paper, a review, etc. Indeed, one of the even though several of the editors there are methods people, and they extensively use tools that can be of the kind of those that are presented here in the Open Science Room and in the hackathon. It could be that some of this neuroinformatics part is less represented. If you feel that is the case, please get in touch with us, and we definitely can make space for a couple of more editors, which would, for example, create Brainhack proceedings and things like that, because they definitely are in scope with the journal. So I don't want to take too much of your time. I will maybe just link to a presentation session we did on Crowdcast some time ago. I guess it was in May. So you can look back at the conversation with me and Conrad. And then there is also this one second. This presentation to the OpenMR workshop that we Sophie and Remy and the other organized in Nijmegen in January. So this is my talk on the current publishing infrastructure, and of which MBDT is let's say one of the possible solution, albeit not the only one. Yes, please.
Thanks, Daniela. So highly encourage everyone to check out the journal and look through the editorial board. Like my impression on this journal is that when it came out is that it is just doing absolutely everything that a journal should be doing in this day and age. It's got a killer editorial board. It's fully open access. It's basically free to publish. It's $10. It's community owned, and they're interested in innovating and progressing scholarly publishing in ways that the commercial publishers just aren't. And they're not in it for the profit, they're in it for the science. And so to me, it's really the journal that we should be supporting. It's the journal that it's the community that we are part of and that have our best interests at heart. But if you look at the kind of impact-based hierarchy that we have in the journal system, it's very hard for a journal like this to get a leg in. And I think that's kind of evidenced in that they've only had kind of the tens of submissions in the last year and a half since it's been founded. Personally, I think it should be in the hundreds or thousands, and we should be getting behind this journal. But I think probably one of the obstacles is that, like for me particularly, I'm an early career researcher, and I am scared that if I publish in a journal that doesn't have a reputation yet, I'm not going to be able to get the next job. But the thing about impact factors is they come around every 2 years. And if we were to all band together and decide that we were going to support this journal for the next 2 years, then at the end of 2 years' time, it would have had access to the highest quality outputs that we can create. And along with that, all of the citations that are going to come to that journal. And that would mean that in a couple of years, it would have a high journal impact factor, a high level of prestige and reputation. And in a short couple of years, we as a community could kickstart the journal that we really need for this time and age. And it would take it to a point where then its reputation and prestige would be self-sustaining, and it would be competitive with the legacy journals. So that's, I guess, what I would like to do, or one of the ideas that we could do for a campaign with Free Our Knowledge, which is get people to pledge in some capacity to support this journal over the next couple of years, whether that be just try to publish one paper with them, whether it's to give them first pick of all of your papers. I'm not sure what the parameters are, and would love to chat with people and we can hash that out. But I guess that's my general pitch for what one of these campaigns could be on the Free Our Knowledge platform. And yeah, we'd love to hear feedback and see what people think.
Thanks, Cooper.
Thanks.
So, Remy, you had a question, or is answered yet?
No. It was answered by Cooper, because I was about, maybe you want to mention how much it costs to actually publish in your journal.
Yeah. So indeed, yeah, the $10 is basically to cover the price of the digital object identifier acquisition and some minimal contribution, I guess, to Scholastica, which is the host. But yeah, this is
yeah. It's like dead cheap, right? Yeah. Cool. Okay. Awesome. I guess people can reach out to either of you easily on Mattermost at the moment, but I guess
sure.
Your email is linked. Cool.
They can, yeah.
Awesome.
I've created a channel for the project, so I'll just post that as well, but it's just HBM hack-FOK, which is short for Free Our Knowledge.
Yeah, fantastic initials. Love it.
Great. Thanks a lot.
All right, gang. I think that's gonna wrap up the unconference. Sorry, it was we couldn't have it run for as long as we planned, but it's been great anyway. Cool. Okay, so I guess we'll be moving on with Adina and DataLad. I'm going to do a very quick introduction to this because there's going to be an introduction for the next one. So
thanks a lot. See you.
See you, Daniele. I'm not sure exactly what's the best way to introduce DataLad, but for me, I would say that if you know about the fact that, for example, you need to do a backup, but at some point you've done backups on an external hard drive and you don't know which version you have here and there, or if you just uploaded data somewhere and it's hard for you to keep track of which version is where, well, DataLad can definitely help you to do that, but as Adina will show you, it can do a lot more than this. And I can tell you that the video that Adina has put together is pretty fantastic, and you will, definitely just stay around. It's going to be fun. Okay, let's wrap this up.
Thank you, and I'll be just ending this broadcast and setting everything up and informing all you.
See you later, all.
See you.
Results. Should you be wondering where I am, I'm in a rabbit hutch. Should you ask yourself, why the hell is she in a rabbit hutch? Then I would say, well, why not? Given that the pandemic limits where we can currently go and the company that we can currently have, I chose to be in the most exciting place with the most corona-conform company I have access to. And this is why I'm joined today by the two cute bunnies, Emil and Nala. You can see Emil munching a carrot right next to me. This has the great advantage that you have the chance. Hi, my name is Adina, and in this OHBM Brainhack train track session, I'm going to be talking about DataLad. DataLad is a data management and data publication multi-tool, and I will be spending the next 1.5 hours showing you how it can be used to version control your next project in all aspects, or how it can assist you in the reproducibility of your results. Should you be wondering where I am, I'm in a rabbit hutch. Should you ask yourself, why the hell is she in a rabbit hutch? Then I would say, well, why not? Given that the pandemic limits where we can currently go and the company that we can currently have, I chose to be in the most exciting place with the most corona-conformed company I have access to. And this is why I'm joined today by the two cute bunnies, Emil and Nala. You can see Emil munching a carrot right next to me. This has the great advantage that you have the chance of cute bunny content, in addition to amazing data-led content. Don't worry, I'm not enforcing a software demonstration on two innocent bunnies. That would be really cruel. The door of this incredibly large enclosure is open, and the two can leave whenever they want. As can you, by the way. So if you want to leave this train track or mute me, go ahead. I won't even notice. It's a win-win situation. So, from the middle of Germany, in some rabbit hutch, a very friendly hello to you wherever you may be in the world. I hope that you stay safe during this pandemic and that you've made yourself comfortable and brought a computer with you to this train track session. So, let's get started with DataLad. There are many different use cases for DataLad. One straightforward reason that I use it personally for is to version control all of my personal projects, whether that are data analyses, writing a book such as the DataLad handbook, version controlling my CV, creating presentations and videos like this one, or managing my music library. I call this straightforward because one thing that DataLad does is version control. Version control means tracking changes made to files over time and having the ability to revert changes or view specific states of a file or of a project's history. Unlike version control with tools like Git, DataLad can not only manage small files such as code or other text, but files of any size. This makes it possible to version control 500 gigabytes of neuroimaging data with DataLad, for example, or manage my complete music library. But I have more use cases for DataLad, and so will you. I, again, use it to create provenance-tracked and computationally reproducible scientific analyses. So when I write a paper, then I use DataLad to link data, code, software, and the results, and then I publish all of that to Git repository hosting services such as GitHub to make my work openly and easily accessible to others. And in my home institution, the Jülich Research Center, we use DataLad for really large-scale, fair data analysis projects on supercomputing infrastructure. Other common use cases, for example, concern data publication or collaborative work on analyses. And you may have even other use cases for DataLad. It's an incredibly versatile tool. With my demonstration today, I hope that I can give you an idea of what's generally possible and a good starting point to get going with DataLad. I won't go into all of the details and I won't be able to mention everything that is possible with DataLad. But if my demonstration interested you, then there are resources out there that will get you started with however you want to use DataLad. First and foremost, those resources are collected in what is called the DataLad handbook. You can find it as an HTML version in a PDF or EPUB format at handbook.datalad.org. This handbook is a hands-on crash course on DataLad that you can turn to learn how to use DataLad. It's written in a community effort and it teaches you everything you need to know regardless of the background that you have. Beyond a course-like tutorial, the handbook also contains advanced topics, such as a chapter on scaling up. So if you're interested in version controlling projects that are as large as the Human Connectome project or larger, or run analysis on them, go ahead and read this chapter. And it also contains use cases. Those are step-by-step instructions and overviews on the different use cases that DataLad assists with. Those can be basic, like a general introduction to provenance tracking with datalet, but they can also be quite comprehensive. For example, how to write a completely reproducible paper, or how to implement a central data management and data archival solution on an infrastructural level for a scientific institute. If you want to find out more, visit the handbook at handbook.datalet.org or come to poster 1914 later at the OHBM. So let's start with the boring stuff. Datalet is a command line tool and it has a Python API. So whenever I use it, I either operate it in a terminal using a command that starts with datalet, or I use it in scripts such as shell scripts, Python scripts, Jupyter notebooks, and so forth. In the command line, this is how it looks like. I always start with a general datalet command and then I add whatever subcommand I need. And if I use it in its Python API, then this is the line that I would use to import datalet. And you will later see a script where I show you how this is done. Cool. Datalet builds up on two version control tools, namely Git and Git Annex. They both provide the version control features that Datalet offers. Git Annex takes care of handling large file content that Git wouldn't be able to manage. In order to use Datalet, you will need to have all three tools installed, so Git, Git Annex, and Datalet. However, you don't need to know how to use Git or Git Annex. It's completely fine if you have never used Git before. Datalet tries to hide the complexities of the other tools as best as it possibly can. You can find details on how to install Datalet and its dependencies on all operating systems or using several package managers in the Datalet handbook. It also details how to install Datalet on shared machines, such as high-performance compute clusters, where you don't have administrative privileges, so sudo rights. Once you have Datalet installed, we can go right into this train track. If you have Datalet already installed, but you're not sure whether it is an old version of Datalet, please go and check it now. It is important for this train track session that you have a quite recent version of Datalet, at least version 0.12 or higher. You can do this by typing datalet-version into your terminal. If you have an outdated version of Datalet, then the handbook will also show you how to upgrade to the most recent Datalet version. All of that can be found in the section Installation and Configuration that is shown in the slides. Cool. Right after the installation of Datalet, the very first thing that we have to do, if you haven't done so yet, is to configure your Git identity. If you've never used Git, again, don't worry. The identity that we're providing here with the git config command consists only of your name and email address, and it will be used to associate a change that you make in any of the version control features of Datalet with you as an author. So that's a useful feature to have, and if you don't do the configuration, then Datalet will warn you constantly. Now that you have configured your Git identity, we're ready to use Datalet for the next project. So let's dive into the basic concepts and commands so that you can get an idea of how it can be used and what it can be used for. If you have it installed right now, then I invite you during this train track to follow along with me and use the same commands that I'm using. You can find them to copy and paste into your terminal at handbook.datalet.org. In this demonstration, I'm using content from the basics part of the handbook. This part is a code-along crash course, and it follows a narrative that takes readers through a fictional educational course called Datalet 101. So for the rest of this demonstration, envision yourself as a student in this college course, and the examples that I'm using here are thus not really related to neuroscience, but tuned to this college course narrative. But it will not be difficult for you to link your own use cases to the data-led concepts and commands I will be showing you, because data-led is a completely domain-agnostic tool. So, the foundation, or the most basic concepts that we have to start with, is the dataset. Everything that we will use data-led for happens in so-called data-led datasets. A dataset is the core data structure of data-led, but honestly it's nothing fancy. A dataset is just a directory on your computer that you instruct data-led to manage, and absolutely any directory on your computer can be managed by data-led. You can create datasets as empty directories and then populate them. You can transform existing directories that already have content into datasets to version control their contents, or you can install datasets from elsewhere to obtain the data that they contain. And even though it's not the coolest feature, or it doesn't sound like the coolest feature right now, datasets can be nested in each other, so you can create a hierarchy of datasets. And I will show you later how this feature is quite amazing. In the narrative of the handbook's basic part, we are students, and in the first lesson, in chapter 1, we are creating a data-led dataset to collect all the course materials of the data-led 101 course into. We will follow this narrative to experience some of the basics of data-led datasets, because it's much easier to just explore the stuff instead of boringly have it explained to you. Creating a dataset is done with the data-led create command. This command only needs a name, and it will subsequently create a new directory under this name and instruct data-led to manage it. Here, this command also has an additional option, the -c text to git option. With the -c option, datasets can be configured in a certain way at the time of creation. You can find out about the details of the text-to-git configuration in the data-led handbook, but in general, this configuration is a very useful standard configuration for datasets. You can see when I execute this command that data-led informs what it is doing during the execution. At the end of this command, as with any command that data-led performs, it will print a summary. In this case, it is a successful create operation as indicated by this OK in brackets. And right after dataset creation, there is now a new directory on your computer called data-led 101. If we now navigate into this directory with the change directory command, this is this cd command, and then list the contents of this dataset with the ls command, then we'll see that it's empty. That's not surprising, because we haven't put anything inside of it yet. However, there are some hidden directories at work, and those hidden directories are the version control tools that data-led builds up on. And thanks to these version control tools, this dataset has really cool features. For example, a dataset can record everything that is done inside of it. It can version control all content given to it, regardless of how large this content is, and it can have a complete history that you can interact with, check out previous states, revert, and so forth. Even though the dataset is empty and doesn't version control anything yet, this history is already present, and we'll check it out to just get you an idea of how it looks like and get some core concepts known to you. In general, this history exists thanks to the version control tool Git. Therefore, you can access the history with any tool that shows you Git history. Here we say basic and simply use the built-in Git tool gitlog or Git command gitlog. But if you have other tools that you find visually more pleasing, then go ahead and use them. You can visualize the history with whatever tool you want. When running gitlog, it will show you the history of the dataset as git commits. These git commits are shown in a certain sequence. The most recent commit is always at the top. The commits are created every time that you save a change, and they have particular information in them. One important piece is this 40 character string. This is a so-called commit hash or char-sum or checksum, and it's a string that can uniquely identify any given commit in your dataset. You can also see that each commit has an author and a date and a time of the change recorded. And what you can finally see is that there's a short message attached to each commit. We refer to this message as a commit message. And in general, it's a short and informative summary of what was done in a particular change. Usually, you will need to provide such commit messages. And they are useful for you and others to easily know what was done in any human readable way. The two commits that are currently in your dataset have commit messages that were created by Datalet, though, because those two commits are associated with the creation and the configuration of the dataset. The reason that this history is accessible with Git tools is that a dataset is a Git repository. It just has some more features than a Git repository, and you will get to know them soon. If you're a Git user, therefore, you can use any Git command of your choice in this dataset, and it will just work out of the box. If you're not a Git user, you can still use any Git command, but you can also use all of the Datalet commands that I'm going to show you. Now, because this dataset is really quite boring still, let's put some contents inside and version control them. This first part of the demonstration will show you the general local version control workflows that you can do with Datalet on any type of data. Because this narrative contains an educational class, let's put a few books, such as the readings that you would usually get in a college course, inside of the dataset. For this, I'm downloading a couple of books and put them into my dataset. I'll start, to be neat and orderly, by creating a books directory with the mkdir command, just to have a place for those books to live in. And afterwards, I will download 2 books from the internet. Here, I'm doing this with the command line tool wget. It's just convenient for me to do all of this in the command line, even though the command is a bit lengthy and intimidating. It's just a download. If you want to, you can, of course, just go to the web page that these books are hosted on, click on the download button, and save them in this directory. After all, your dataset just looks like any regular directory on your computer, and you can just save a PDF in whatever way you would usually save a PDF into this. The books that I'm downloading here are free and open source. In general, I can recommend them. They are on the Linux command line and on Python programming. And now that I've downloaded them, I can see how my directory structure looks like by running the tree command that shows me the file hierarchy in my directory or in my dataset. Here I can see that there are the 2 books that I've downloaded as PDFs in the books directory. The question is, how does the version control software that is now working in this directory behave now that there is content inside? For this, I'm simply going to ask the dataset what its current state is. And for this, I'm going to use the datalet status command. The datalet status command is a very helpful command that you should use very often. It reports on the current state of your dataset. Any content that is new or changed will be highlighted, and if nothing has changed, the datalet status report will report on something that is called a clean dataset state. And just as a heads up, the clean dataset state is the thing that you should strive for in your work routines. Always make sure that you commit the changes that you have or save the changes that you have and have a clean dataset. All right. Now this output of datalet status shows you that the directory with the new PDF files is untracked. And this means that it is yet unknown to any of the version control software. So as a first take-home message, this shows you that you need to explicitly give any content to Datalet to have it version controlled. It's not enough to simply add it to a dataset. How can we instruct Datalet to version control these contents? We save them with the datalet save command. This is the first time that we're using this command, and this is the first time that you need to specify a commit message yourself. So what we're doing is datalet save and then the -m option, to which we can attach a concise summary of what we have downloaded, for example. In this case, I'm just describing the books that I have downloaded. Afterwards, Save reports that it has added those books to the dataset, and Datalet now knows about the books directory and the 2 PDFs inside of it. If I use git log -n1, I can take a look at the most recent commit in my history, and the information, the way that this information is displayed here, is again something that one needs to get used to if you're not used to seeing Git histories, but you can get used to it quite fast. In any case, thanks to the commit message, we know exactly what has been done by whom and also when. Now, this was already really easy just to save. So you already know how to version control content with Datalet. Let's work on some best practices just because this was so easy. You might have noticed that the datalet save command that we just ran saved all of the untracked changes that were present in the dataset. And this is the default of datalet save. Datalet save, if you don't specify anything else, will save all of the untracked modifications or unsaved modifications in your dataset. And that's behavior that's sometimes inconvenient. One great advantage of a dataset's history is that it allows you to revert changes that you're not happy with. But this is only easily possible if the units are single commits. So if one save commits several unrelated files or changes, then those are hard to disentangle if you ever want to revert some of those changes. But if you provide atomic changes that are one meaningful unit that can be reverted without affecting any other change in your dataset, then you're good to go. So how can you do this? One way is to specify precisely which files you want to add. And this can be done by simply appending a path to the datalet save command. We can show you how this is done by simply downloading another book. First, again, we download it, then check the state of the dataset with the datalet status command, and then we'll save it. So datalet status shows that it's an untracked file as expected. And if I now want to demonstrate precisely how to specify this exact file to be saved, then it's a datalet save, an informative commit message, and a path to this new file. Awesome. Before we move on to the next demonstrations, let's take a look at files that are frequently modified, for example, code or text. To try this or to show it to you, I will create a file and modify it. In the context of an educational course, I will create a file which collects notes on the educational course Datalet 101. So I'm just creating a file where I frequently write notes about the Datalet commands I'm learning into. The way I'm writing these notes is a bit convoluted because I again want to do everything inside of the terminal. And this is why I'm using here docs. This is a form of Unix redirection to paste text into a file. So the first note that I'm writing is just this middle of the line I'm executing. So it's one can create a new dataset with datalet create path. The dataset is created empty. And executing this line will write this to a new file, notes.txt. You can also just open up any editor of your choice and then just write the notes in any way that you would usually write notes or text. Now a datalet status will, as expected, report this file as being untracked. And we can again save it with a datalet save command and a helpful commit message. Because this file is the only change that's present in the dataset, I don't even need to provide a path. Let's now add another node to modify this file that is already version controlled. Again, I'm doing this here with a here doc. The next datalet status report does not report this file to be untracked, but because it differs now from the state that it was saved under, it is reported to be modified. And how can I save a modified file? Again, with datalet save. If I take a look at the history of this file now, again with git log, then the history neatly summarizes all of the changes that we have done. This means that taken together, local version control is really easy with Datalet. It requires a dataset, and afterwards all of the modifications that you do to this dataset can be saved regardless of the size or type using Datalet save. If you save only meaningful units of change and attach helpful commit messages, then it will be easy for you to create a dataset history that you and your future self and others can understand right away, and that you can also interact with well. Cool. So to summarize everything that has happened so far in this train track, here's a short overview. Datalet create creates an empty dataset. There are useful configuration options. You've seen text to git. There will also be Yoda that apply suitable defaults to your datasets, and you can read up on all of the details on them in the Datalet handbook. Dataset has a history, and this history is used to track files and the modifications done to them. You can explore it with any tool that is able to explore git log. My personal favorite, for example, is TIG, T-I-G. That gives a really nice, beautiful, visually pleasing summary. Datalet save records the dataset or file state to the history of your dataset. And if you attach a concise commit message, then your future self and others will thank you for this human readable information that makes your dataset history understandable. Datalet status is a command that you will frequently run because it is a command that reports on the state of the dataset. And just to reiterate, a clean dataset status is good practice. So always try to have all of your changes saved at one point. Cool. So just by using version control, you can already improve your work greatly. You will work more cleanly, you'll have less cluttered directories, and you'll also have the safe feeling that comes from the certainty that no changes that have been added at one point to your dataset can ever be lost. That's quite nice. Oh, they cuddle. All right, let's get to the next topic in this demonstration, consuming datasets. There are many awesome datasets out there that you can install on your computer. For example, we have public datasets with hundreds of gigabytes of openly shared neuroscientific data that you can use for your analysis. All of the datasets on OpenNeuro, for example, are available as Datalet datasets. And I can show you now how to install a Datalet dataset. The educational course does not download a dataset from OpenNeuro. But here we're installing another public dataset that is a podcast series that is called the Long Now series, the Long Now seminars, sorry. First, I again will create a subdirectory in my dataset for this to keep everything nice and orderly. Here I'll call it recordings. Afterwards, I install the dataset that I'm interested in. This can generally be a path, or it can be a URL, and if you check out the Datalet handbook, then you can find many more sources that you can install datasets from. And in this case, the dataset lives on GitHub. So in order to get it, I will provide its URL to the Datalet clone command. Importantly, I'm also attaching a path at the end of the Datalet clone command that points to the directory where I want to install this dataset in. That's the new directory I've just created. And also importantly, I'm installing this dataset as what is called a subdataset of Datalet 101. In other words, I will nest the two datasets, Datalet 101 and the Long Now dataset, into each other. Then I have a super dataset and a subdataset. And this is done by providing a -- dataset flag and a path to the root, in this case it's just a dot, to the top level dataset. Here's how this subdataset looks like right after I cloned it. There are new directories in my Datalet 101 dataset, and if I navigate into these new directories and then list the contents of one of it, then there are hundreds of MP3 files. And given the amount of files that we're seeing here, it is really quite surprising how fast the installation of the dataset was. I personally would expect that it should take much longer to download a directory with that many files. But here's the crucial and incredibly handy feature of data-led datasets. At this point, right after cloning, the dataset only contains small files, for example, the README files, and what we simplify or refer to as file availability metadata. All of these MP3 files that you can see in here don't have any file content yet. Think of them as only being file names, but not having content. So if I would try to play one of the recordings, then this would fail. Here I'm trying to open it up with the VLC player, and you can see that the poor tool complains that it just can't find the file that I want to open up. This is weird to get used to, but incredibly handy. This makes this dataset really lightweight and fast to install, but because I can still explore the hierarchy of the files in this dataset, I can check what is available. So let's take a look at the size of this directory. I'm using the du command to show the disk usage. And this dataset right after installation is tiny, because I've told you file content is not available yet, only small files. But I can also find out how large the dataset would be if I would get all of the file contents. And for this I can use data-led status with the --nx flag. So in total, it appears that in this dataset would be more than 15 gigabytes of MP3 files. And because I've installed this dataset, I now have access to these files should I want to. File retrieval, that means getting the file contents actually down to my computer, is done with the data-led get command. This command can retrieve individual or groups of files, directories, sub-datasets, whatever you specify, and then download their contents. I will do it for one podcast title, and you can see how it summarizes the operation in the end with a OK to indicate that successful retrieval happened. Afterwards, I can actually open up the file content, and it is now locally available. So I can now listen to my podcasts. And if that would be an open neuro dataset, I can analyze the neuroimaging data I have just downloaded. If we retrieve more files, including one that was already retrieved, so I'm retrieving 3 files in total, but one of them already has their content locally available, then you can see that it is not re-retrieving the already existing content. It will summarize this file to be not needed, and the other one's content is retrieved. Cool. Now, imagine that this dataset wasn't about podcasts, but, for example, the Human Connectome project. We make the HCP data available as a dataset that you can install from GitHub, just as you have with this podcast repository. That makes it very easily accessible. When you clone this dataset, then in its entirety, with all of the sub-datasets that the HCP dataset that is on GitHub has, it will have 15 million files and 80 terabytes of data. And that's a lot to store on a single computer. However, if you take into account the features that data-led datasets have right after cloning, you realize that even though you have access to all of the 80 terabytes of HCP data, the dataset that you have downloaded will be incredibly tiny. And you can download only those files that you are currently needing, because probably your analyses of the HCP data will not require 80 terabytes of files or all of the 15 million files, but maybe just a subset of them. Cool. So this is already a disk space saving approach to things. By still having access to all of the data and only retrieving that data that you currently need, in theory, you can have more data on your computer than your hard drive has available disk space. That sounds cool, doesn't it? And we can take this further because now imagine that you have run an analysis on the HCP data. So in theory, only your results are what is important. You can always re-download the HCP data, but your results are unique and you should save them. Let's take a look at this in our narrative. So let's say that you've listened to a podcast and thus you don't need the content anymore. Then you can use the command data let drop to remove the content. In its place, after you've dropped the content, there will still be the file name, so to say, but no content, just as it was right after you cloned this dataset. And because datalet knows where to get the data from, it can just be re-retrieved. So if I run datalet get again, then I have downloaded it again. That's quite handy. Note though that dropping and re-retrieving data does only work for data where datalet knows the origin. So you can drop data from installed datasets, for example, and data that you have attached origin provenance to, but you shouldn't attempt to drop data that you've just added to your dataset because this operation would permanently remove the content from the dataset, and datalet get will not know where to retrieve those files from. So don't drop the PDFs that you have added to this dataset. Should you attempt to do this, datalet will warn you though and not let you proceed without forcing. Cool. So at this point, you have the means to version control arbitrary large contents, and you can consume existing datasets, and you can save disk space by getting or dropping data on demand. One other aspect that is useful to understand is dataset nesting. Let's take a look into the history of this LongNow subdataset. We can see that it has preserved its history completely. There is no notion about PDFs or nodes that we created in the Datalet 101 dataset, but here we can see the complete evolution of this dataset. I can find out who created it and what was done to it. This means that this dataset has kept all of its provenance. How does the addition of the subdataset look like in the top-level dataset? If we query the Datalet 101 history, then there also will be no of the commits that we have just seen, no commits about MP3 files, or any of the other commits. And instead, we can see that the super dataset recorded the LongNow dataset as a subdataset. This means that it recorded where this dataset came from. So here it is its GitHub URL and what version it is in. Do me a favor and memorize this commit char-sum that is referred to as subproject commit here for a short time. At least to start the first few characters of it. I'll navigate into the subdataset again, and here we notice that the char-sum that we have memorized is the char-sum of the most recent commit in the subdataset. So what the super dataset recorded is the most recent version. And thus, by nesting datasets, you have a way of linking a dataset in a precise version to another dataset. Let's quickly summarize everything we have seen on dataset consumption and nesting. You can install a dataset using datalet clone, either from a path or a URL, or if you read the handbook, also from a range of other sources. In this example, we have seen a dataset being installed as a subdataset inside of an existing dataset by specifying the --dataset option, and a path to the root of the top-level dataset. But you can also install datasets on their own outside of existing datasets by just not using the --dataset option. Right after the installation of a dataset, it is really lightweight. There are only small files and metadata about file availability present, and you can retrieve any data that is not yet present using the datalet get command whenever you need it. If data doesn't need to be present locally anymore, then you can drop it using the datalet drop command to save disk space. And finally, datasets preserve their history. Thus, I can find out things like what was done to a dataset, how did a file came to be, or who did work on this, and much more. And when nesting datasets, the top-level dataset or the super dataset records the version that this subdataset is in. But now, what makes this last point so special? It's sometimes a bit hard to grasp if you have these simplified examples. In principle, it allows to join independent components for, say, a study. Let me give you a concrete example of this to make it a bit more clear. For this, I'll briefly abandon the handbook narrative, and instead I'm showing you a paper that I have written. Thanks to DataLad, this paper is completely and automatically reproducible, and I'm able to share code, data, manuscript, and code execution on GitHub. So if you want to, check out the GitHub repository in this link and try it out yourself, or read all about the details on creating such a reproducible paper in a dedicated use case in the DataLad handbook. This repository is a dataset that I published to GitHub. The top-level dataset contains the LaTeX sources for the manuscript and the code that computes the results I report in my paper. The dataset also contains subdatasets that contain the various data that this code is executed on. And I set everything up in a way that figures and results can be computed locally and are directly embedded into the manuscript after the computations have ran. With such a repository, I can not only share my code and data, but everyone can simply recompute every result of my paper and validate its claims. And all of that openly available on GitHub. That's quite neat. So what happened while I wrote this paper was that data for my computations changed because a mistake was fixed. With DataLad, though, I was able to simply update the data to its fixed state and record which version of the data my computations are based on. Let me show you this in a bit more detail. This way I can also show you how cloning nested datasets feels like. So to dive into this, I clone this dataset from GitHub. Afterwards, I can check out the subdatasets of the top-level dataset. I can do this with the command datalad subdatasets. This lists all of the available subdatasets of the current dataset. One of the subdatasets is called Remotnov, and that's a dataset that contains the source code for a Python package called Remotnov used in eye tracking analyses that this paper is about. Now, after cloning a dataset, its subdatasets will be known, but just as content is not yet retrieved for files in the datasets, subdatasets of datasets are not yet installed. So if I navigate into an uninstalled subdataset, it will appear like an empty directory. You can see that if I list the contents, there's nothing. In order to install a subdataset, I again use datalad get. This command doesn't only retrieve file content, but it also installs subdatasets. So if you want to be really lazy, you can just run datalad get --recursive and then -n in the root of a dataset to install all of the available subdatasets down the hierarchy of datasets. The -n option prevents data from being downloaded. It is short for --no data. The recursive option recurses into the hierarchy of all of the datasets. And here I'm limiting how deep I actually want to install datasets because this dataset is really quite nested. Okay. Afterwards, I can again query which subdatasets are available now in the Remotnov subdataset, and here I can see, oh god, there are even more subdatasets in this dataset here. Those subdatasets contain data that is used for testing and validating the software performance. And at this point, you really might be sick of seeing subdatasets. Because what's the point, I guess? Well, what is very useful is that subdatasets modularize my paper project. And keeping things modular can make project components more reusable and the overall project less cluttered and more understandable. And by nesting the modular components, I can flexibly link everything that I need for a given project, while each component preserves all of its history and provenance. For example, the top-level dataset contained code and manuscript for my paper. This is one standalone component that is useful. Another sub-dataset contains the data that I'm running the code from the super dataset on. This data can be used in more than a single paper though, so I'm keeping this as a standalone dataset and just link it in a precise version to my code and manuscript. This way I can use the dataset easily for all kinds of analysis simply by installing it into the dataset that I currently develop my code in. The Romotnov sub-dataset contains the Python package that the paper is about, and this on its own is again a nice standalone thing. And the validation data that the software uses is again also used in several contexts, and thus also standalone datasets. Now, because all of these datasets are linked as a nested hierarchy of datasets, if I share my paper with you, you can go from the finished paper back to the raw data that I base my analyses on and get a complete overview of what I have done should I decide to share all of that. And this aids the reproducibility and transparency of science greatly. I'll elaborate on the principles behind this a bit more later, but let me first show you how, in general, important it is to version data and link precise dataset versions. One of the validation data sub-datasets came from another lab that shared their data. And after I was almost finished with everything and was writing the discussion, I came across a paper that reported a mistake in this shared dataset. I checked, and the mistake was still present in the data that I was using. So if you go into the history of this specific sub-dataset and check it out, then you can see that at one point I contributed a fix that changed the data. The data is now fixed, but this nevertheless means that there is a difference in the data that existed in 2018 and the data that existed in 2019. And changed data is a very dangerous thing to the reproducibility of science, because changed data usually also means changed results. But because everything here was linked as data-led datasets, I was simply able to update the data to its most recent state, and then rerun all of my computations automatically, embed all of my results automatically, and have correct results based on fixed data. And if I wanted to, I could even go and check, for example, how robust my results are against mistakes like that by resetting this dataset to a previous state and then rerunning everything again. So having data-led version data is, from my personal experience, a really useful thing to have, and a great protection against unknown changes in data that can make data potentially irreproducible if you're not aware that your data changes. Cool. This has hopefully given you a first idea on why nesting datasets is useful, why version controlling data is important for the reproducibility of analyses, and how complex but yet surprisingly understandable data-led datasets can be combined to publish reproducible research objects. And that already brings us to the next part of this demonstration: reproducible analyses. Not only can I version control data and consume data with data-led, I can also create datasets with data analyses in a way that my future self and others can easily and automatically reproduce and recompute what was done. And in order to do this, I actually don't need to do much. I need to comply to some basic organizational principles for datasets, and I need to tell data-led to record how analyses are conducted. The results of such an effort will be a dataset that has a provenance record on how results of an analysis came into existence. And it also has the ability to automatically re-execute an analysis. And I'm going to show you how this is done. But first, let me give you a wrap-up of these basic organizational principles I talked about. If you're interested in the details of them, then you can read up on them in the Data-led Handbook in the chapter on Yoda principles. You will also recognize them from the setup of the reproducible paper repository that I have just shown you. So, first of all, you should make sure that your dataset is clean and modular. The analysis code should be developed in the top-level dataset, and the input data for the analysis should be installed in its precise version as a subdataset, for example. So you have the code component and you have the input component separate, yet linked as datasets. Next, you shouldn't touch the raw data. When you compute results for a data analysis, don't save them into the input dataset. Instead, keep the subdataset clean and untouched and collect the outputs in the top-level dataset. This makes it easier to understand your directory structure. So if you include outputs and inputs into the same directory, it will be hard for others and your future self to understand which is input, which is output. But importantly, adding the outputs to the dataset that you computed your or developed your code in and ran your code in will also help you to link your results to the code and the computation. Further, keep super datasets self-contained. Write scripts that reference subdatasets or files with relative paths instead of absolute paths. This way you can share your dataset and the scripts will run successfully on other computers that have a different underlying file structure if they only reference files or subdatasets as relative paths. And finally, you should record as much provenance as you can. So you should link datasets by installing them as subdatasets. You should record the execution of commands to track which scripts produced which output, or even attach a software environment to the execution record. And if you adhere to these principles, then you can create data analyses that can be automatically and even computationally reproducible. I'll show you the basics of this in a small data analysis project in which I will run a simple classification analysis on some dataset. This is a toy example, and it's simplified to make my life easy and to not have you bother with understanding the computation, but the principles that I'm showing you can be applied to a dataset, to a data analysis of any complexity. So here, what I'm doing, I'll take this very known iris dataset and run a simple k-nearest neighbors classification on it. Importantly, in this analysis, I will make sure that I not only record how I run the computation, but I will also make the computation automatically reproducible. But first, let me set up my analysis. For this, I create a new dataset. Here, I use a different configuration procedure that is called Yoda. This configuration sets up a helpful structure for my dataset with a code directory and some README files, and it applies helpful configurations. Next, I will proceed by installing my input data as a subdataset to keep everything nice and modular. For this, I created a dataset with a CSV file that contains the iris data, and I published it to GitHub. Here, I'm installing it into a directory that I call input. The last thing I need is code to run on the data and produce results. For this, I have posted a k-nearest neighbors classification analysis script that I'm currently printing to the screen and then save into a script.py file in my code directory. This script is written in Python, and it uses the package pandas to load the iris data, the package cborn to plot the data and then save a figure as a result, and the package sklearn to perform a k-nearest neighbor classification and save those results. I have also, as you can see, included a datalet get command in this script, just for you to see how datalet can be used in Python scripts. And what you should note here is that all of the paths that I'm using in this script are relative and not absolute. So they only point into, for example, the subdataset or to the root of the superdataset. I have copied the script into the code directory, and running datalet status tells me that it is unsurprisingly untracked. So let me quickly save it to the history of the dataset with a datalet save command. We can also pretend that this script is really complex, and I have spent weeks working on it with plenty of datalet saves in between. If I want to, I can also identify this finished state of my analysis script with a tag, an identifier. I can attach this with the -- version tag option of the datalet save command. Now with my input data installed and with my code script set up, I can in principle now run Python, so interpreter, code script.py to execute the script and produce results. But if this script or this analysis would be more complex, or an analysis of one of many, then it will be bloody difficult to associate the outputs with the script that was run or with the data that it was run on after, let's say, 2 days. It's very hard to remember such things. And the challenge that datalet helps me to accomplish is to run this script in a way that links the script to the results it produces, and also to the data that it was computed from. I can do this with a specific command that is called datalet run. I'll visualize it here, and I'll walk you through the figure in a bit. Datalet run, in principle, is a command that captures the execution of any command, the execution of a script, the execution of a terminal command, and then links the command that was run to the output that was produced. So it takes the dataset state before running the command, then runs the command, checks what changed in the dataset, and saves all of that, linking it to the command that was run. So if I'm running a script, I can link the outputs that are produced by this script to the script and the command I called it with. In principle, this is really simple. So let's start. First of all, we need to have a clean dataset. Afterwards, I'll compose my datalet run command. I give the command that I would execute, in this case Python code script.py to datalet run. And datalet will take this command, run it, and save all of the changes in the dataset that this leads to under the commit message that I have specified with the -m option right at the start of this command. So this already associates the script with the results that will be produced from it. But the command can even be more helpful. It can also help to retrieve the data that is necessary. So I can specify the input data in the command, and datalet will get the data beforehand, because even though I have installed this subdataset, I haven't retrieved the data that is inside of it. Here in this particular command, I also specify the output of the command. In principle, this is not always necessary, and to understand fully what this does, please read chapters 2 and 3 of the Datalet Handbook. But in general, specifying these outputs will allow me in a couple of minutes to rerun the command and let me update outdated results. Now, if I run this, datalet creates a commit in my history. This commit has the commit message that I gave to this commit as a human-readable summary of what was done, but this commit also contains the produced output, so it's already linked. And importantly, the commit has a machine-readable record that contains information on the input data, the results, and the command that was run to create this result. This machine-readable record is particularly helpful. So it's not the most readable thing, but it's not meant for human consumption. It's meant for machine consumption. Because now I can instruct datalet to rerun this command so that I don't have to memorize what I had done, and the people that I share my datasets with don't need to ask me how a particular result was produced. They can simply let datalet tell them. And re-executing a command that was ran through datalet run is done with the datalet rerun command. For this demonstration, I have prepared an analysis dataset and published it to GitHub, just the same analysis dataset that I have created with you right now. And now let me simply clone this repository and then use the datalet rerun command to rerun the run command that I have used. So imagine that I'm a collaborator of myself. I received this dataset, I want to find out what was done, and I'm simply rerunning the exact computation. For this, I could use something like a tag, but here I'm just checking the checksum of the run commit and put it into the datalet rerun command. Datalet will then read the machine-readable record that is attached to this commit identified by this checksum and then recompute the exact same thing. Because I have specified everything that was necessary, the inputs and the outputs, datalet will be able to retrieve the data and update the outputs, for example, should the data change, and so forth. And now I have reproduced the results that I computed here. Cool. So this allows others to very easily rerun my computations. But honestly, it also spares me the need to remember how I executed my script. I have scripts that have many command arguments, and sometimes I really can't remember how to execute them. And if I execute them with datalet run, I can simply rerun them and have datalet take care of this memory task for me. And that's really helpful. What I could also do now is I could alter my script a bit, for example, change the color scheme of the figure that I have created, and then simply rerun the command again to update the figure to a new color scheme. What is also useful in this dataset is that I can simply ask a result where it came from. And this can be as simple as just running the git log command on this result. And afterwards, the git history of this command will tell me all of the commits that are associated with it. So with this very simple information, I can find out which script produced this result on which data. I can even find out on which version, and who did this and when this was done. Very useful if I ever want to blame someone for a particular computation, for example, myself. Cool. But let's now take reproducibility one step further even. Let's say that I share this dataset with you and I want you to recompute my results. If you, however, don't use Python regularly and don't have the required Python packages available, running the script and recomputing the results will naturally fail because you don't have the software available. In order to be computationally reproducible, I also should attach the software that is necessary for a computation to this execution record. And this is particularly helpful if you're using software where different versions of it produce slightly changing results, or if it's software that's just a pain to download. So if you want to spare others the pain of setting up their software environments just so that they can recompute and validate your results, do them a favor and attach software environments to your computation. And the way I can do this is with a DataLad extension. DataLad has several extensions that come with special functionality and add DataLad commands to the commands that DataLad core already has. In this case, the DataLad extension is called DataLad containers. You can install any DataLad extension with the Python package manager pip. So in order to install this extension, I can simply run pip install DataLad containers. This extension is really helpful because it allows me to attach software containers such as Singularity or Docker containers to my dataset, and then it will execute the commands that I'm running inside of these containers. With this, I can not only share my code execution and my data, but also the software that everything runs in. And here's how it works. First, I attach a software container to my dataset using the DataLad containers add command. This command takes a name of the container, here I call it software, and a URL or a path to where this container can be found with the --URL flag. You can have a container locally and then point with a path to it, or as in my case here, point to a URL on Singularity Hub or also Docker Hub. And what this command does is it records the software in the dataset. So you can see that the container is currently being downloaded and then saved into my dataset. Afterwards, I can rerun my analysis in the software container using the DataLad containers run command. This containers run command works just as the run command before. I only need to additionally specify the container name. So if you now were to rerun such an analysis that was run with DataLad containers run, DataLad would not only retrieve the input data, but it would also retrieve the software container and then execute the command with the code that you provided on the data that is recorded in the execution inside of this container. And thus, you can make sure that your analysis is as reproducible as you can potentially make it. Cool. So to summarize this last demonstration, DataLad contains functionality to create reproducible analyses by linking data, code execution, and software to the results that it produced. This helps others to understand and recreate your analyses, but it will also be helpful for yourself to produce your own results and keep track of what you have done. I hope that this demonstration gave you some interesting glimpses into the basics of DataLad and what is possible with it. There is a lot that I didn't explain yet, and there is much more that you can use DataLad for. All of this is detailed in the DataLad handbook though. So if my demonstration intrigued you and you want to find out more, then go ahead and read the DataLad handbook, check out the pieces that you need, and learn how to do the project that you envision. You can, as a start, also, for example, clone publicly available datasets such as the ones from OpenNeural to just explore datasets a bit more and explore the looks and feels of them. If anyone is still listening at this point, thanks a lot for your attention. I'll finish with acknowledgements and with many thanks to the creators and contributors of DataLad and the DataLad handbook. If you have questions, then reach out, for example, in the DataLad Riot channel or on GitHub of DataLad or of the DataLad handbook. And if you want to, you can contribute to the development of the DataLad handbook, for example, with your own use case or by simply making the book more accessible or understandable. I appreciate everyone who reaches out. I hope that I will be able to meet you in person, tell you more about DataLad face to face, and in general that we all get safely through this pandemic. I wish you happy further train track, and if I'm here in this train track session, then bombard me with questions about DataLab. Bye from my side, and see you in the chat.
Watching us.
Wow.
Hello, everyone. We are at the question and answering session. One of the questions were about the Windows bug, which I couldn't read about, but you answered that. I saw that.
Yeah, I posted a workaround. That's a bit inconvenient. I'm very sorry that we ran into a...
Oops, sorry.
Okay, sorry. Yeah, very sorry. Very inconvenient that we ran into a Windows bug during a software demonstration. Happens on Windows more often than in any other operating system. But there are ways to get around this, and we've noted it, so we hope that we can fix it. Thanks, Robert.
So I'm not seeing any other questions, but if any people just write on the chat, I can read them for you, or if you have anything to mention, Ben or you, in addition to your very nice presentation with rabbits, just feel free to add.
Maybe I can pitch my open science room demonstration, where you can see a little bit more dense data-led content. It's airing on June 24th, and there I'm showcasing different things, starting slightly less basic, but I'm showing how to install HCP data, run analysis with fMRI prep on the data, and then publish it to a public repository. So if you're interested in that, it also only takes 7 minutes to watch. Please join.
Perfect. I just invited Remy to stage because I forgot him, sorry. Meanwhile, Hao asked that she tried to create a dataset on remote server with 30 subjects. It was really slow, but worked fine. Would it be a potential reasons? Yeah, I don't have so much details. She added.
Okay, I have to.
Oh, you can read the question. So yeah, that would be nice.
I'll give that to Ben.
Maybe I.
Yeah, but
if you want to have Hao on stage and she can ask the question herself, then you can actually chat about it. That would be a bit more. I'm just going to vacate my seat, and then she will have Hao just come on stage so that you can have a chat about it.
Okay.
Okay.
I'm just inviting Hao. You might use her on screen, yes. It's really handy when someone asks the question. I don't need to search for the name. But I know how. Okay, invited and waiting for the connection. Hey.
Oh, thanks very much. That was a really dumb question. Thank you for your presentation. That was...
It's not a dumb question.
Oh.
So if you're asking why it potentially could be slow on the remote server, of course there are a lot of potential reasons, but the main thing to look at is the file system. Because everything that DataLab does itself, and that is not just downloading things or something, is relatively heavy on the file system, or can be. And if you have, say, an NFS mount or something, that can slow down things considerably, and there's nothing we can do about it. It's just that the file system operations take a long time. So that really depends on the setup you're running there.
Yeah. So there's no immediate solution if I want to, say, put data on the university HCP. And yeah.
Yeah, no, not without looking at what's the exact setup on your server.
Yeah, that's a bit complicated, and I understand that.
Yeah.
Yeah.
At least on an occasion like this, right? And if it works fine on your laptop, then it should be clear that in generally it works, and everything else depends. As I said, NFS mounts or Samba server in between or whatever it is might be a big burden for performance.
Yeah. I might talk to the sysadmin about that, but it's not going to be successful most of the time. But I'll try. Thank you.
Yeah.
Thank you for the question. I can keep inviting the people who are asking questions. It felt more interactive for me. I don't know if you want that.
Yeah, it's nice.
I just invited. It's a really nice question for me because I'm working on big data, so I need to learn the ways of scaling things up. Waiting for the invitation to come. No, it rejected. Okay. Okay, we just answered that.
Can data let scale beyond 500 gigabytes? Yeah. So the largest dataset we're currently version controlling is the Human Connectome project. Those are 80 terabytes. The important piece of information to keep in mind is that this is not in a single dataset, because where we do not run into scaling issues with the file size or the amount of data in terms of gigabytes being version controlled. GitNX can do all of that really well. The amount of files is a problem that Git runs into. So if you have 100,000, 200,000 files, then this can become a problem. But what you can do with DataLet, because of the nesting capabilities, is to just create plenty of datasets and nest them in each other. So for the Human Connectome project, there is one super dataset and then about 5,000 sub-datasets, which gives us a manageable amount of files in each sub-dataset, and yet all of the datasets are linked. And if you go to the super dataset, you can clone it as one thing and then install all of the sub-datasets, for example. And the next large project that we're tackling is the UK Biobank. And I'll keep you updated in the DataLet handbook on how that goes.
Wow. Sounds really exciting. And if there are no other questions, I'm just finishing and going on to the wrap-up session. If you don't have anything to add, or if you have, please do. I don't know, in chat, I noticed some questions, but
I think Leonard already answered that question for me, so thanks again, Leonard. Yeah, and thanks so much for everyone's attention.
Thank you. It's been really fun. Now I'm ending. It's been really great to see you. Oh, another question. Yep. About nesting. I have an independent sub-dataset as input, then I have a code operates on this dataset and creates output that can become an independent dataset. I'm not sure what I'm reading. Sorry.
I'm also not super sure. Then again, I could. Yes. You? Okay. Yeah.
So if I get that right, that question is about how to link dataset to each other in terms of sub-datasets. And you suggest that you have the output folder be just another sub-dataset. Of course, technically you can do that. We would not recommend that. That is against what Adina mentioned are the Yoda principles. And the idea is that it is better in terms of reproducibility and how to trace things back, that the output knows where it came from and what it refers to. So the input should be a sub-dataset to the output dataset, not the other way around. And if you go with a structure that has, say, an input data set and an output data set and a super data set that binds them together, then you still have a unit to get everything, and you have that binding, but you lose the reproducibility because the output data set cannot refer to the input data set because the input data set isn't part of it, right? But that is not a technical limitation. You can do that. We would just not recommend that.
Thank you. Thank you for the explanation and the great answer. So far we answered 3 questions, and if users and people have some questions, they can reach out to you from Twitter, Mattermost, and whichever channel you prefer.
Yeah, definitely. Or just create an issue on GitHub.
Yay! Yeah, GitHub is the best way. I forgot that. Yep. Thank you so much.
Thank you.
Hey.
Bye.
Yes, we are live again. Hello, everyone.
Hello.
Hello, hello, hello. Okay, so today went smoothly, or at least smoother than yesterday in terms of the train track. Yeah, we're getting better, right? We're getting better at this. It's like tomorrow is going to be just freaking amazing.
I hope that. If
yeah,
I didn't
exactly.
break anything.
Yeah, let's okay, let's not just like jinx it, because otherwise that would be bad, right?
Touching wood.
Yes, exactly, right. It's just like
Yeah.
Brilliant. Awesome. Yeah, I'm also curious of how things are going on the projects. I see that some people there's a couple of projects. Hello, can you still hear me? Everyone is frozen.
No,
yes.
We can't hear you.
Okay, cool.
Yeah.
Some of the projects that I follow on GitHub are getting like pull requests and stuff is being done. So I suspect there's a lot of activity in the background we don't hear about. So yeah, sort of looking forward to see what's going on and have a wrap up tomorrow. But I guess if anyone wants to come on stage and tell us, hey, we've done this amazing thing today, just give us a shout. We'll be happy to share the stage with you.
We are here.
You wanna come and tell us about how things are going, Johannes?
I just invited him.
Cool. And if you're hearing weird noise coming from my end in terms of background, it's just because we're having a massive thunderstorm right now in Brussels. So this is entertaining.
Do you think it's coming at me afterwards? Like
I have no idea. It's not exactly like I had time to check weather forecast today.
Come on.
Though I had time to eat. I actually just tweeted about that. You know your event is going okay if you actually have time to eat as an organizer. It's like, good.
I took time to eat as well. I think eating is important. Actually, that's something maybe we should improve for next virtual event. I found that issue a bit difficult. Like, it's hard to put in break to eat because it's a different time for everyone. But at the same time, having a schedule with no specific time to eat is just a bit intense. So I'd be happy to hear if we could find a middle ground.
If people have like some feedback for us on like how to best adapt this, definitely.
Yeah,
hey, Johannes.
Hey.
So I'm kind of 100 kilometers north of Remy, and we have 32 degrees. I just want to share this right now. So it's
wow. Okay.
It's very summery in my room. But I think the thunderstorm's gonna come over later today in like 2 hours.
Okay.
Where are you based?
In Nijmegen.
Okay.
Yeah.
Because here it's like 20-ish.
Yeah, he is 32 with a lot of bugs already, but this is why I have to open my door. So we are a very small group, but we made quite some progress now. We are tracking a lot of EEG pre-registrations, and we also reached out to Chris Chambers, who's the editor on Twitter. So now I got a quite good list of existing registered reports, and we are coding those now. I found some very interesting titles. So I saw for the pre-registration on nursing rhymes in EEG. So that was quite nice. And something on paranormal beliefs and paranoia in EEG. So you get to know a lot of interesting research topics like this.
yes, things you would not have heard about otherwise,
No,
right?
no, exactly. Yes. Because
Cool.
I think 2 or 3 people from the US hub also we're gonna continue, and we're gonna have a meeting at 5 p.m. Central European time, so in 2 hours. And then if people want to join, they can still join.
Cool. Brilliant. Yeah. I think yeah, you might get people in the Americas hub definitely interested in this. That'd be cool to see how this is going. Nice.
Really great. So I'll be removing you and inviting someone else.
I'm tempted to if Pilou is around, I'm tempted to have him on stage because I think they were having some nice time in the cafe in Gathertown, and maybe we can have maybe if he's around, he can, because I was hanging out there this morning, and maybe it's if he's around.
He's not live. I'm checking, but he's not live.
Too bad, but I think he posted a message earlier on Matamo's saying that this is actually a cool way to actually just have people hang out together. You just say, hey, I'm going to be there, and everyone just people just drop by randomly, and you have a bit of a chat and a catch up. It's
yeah, we can just write at Matimos to come to the broadcast like message.
Well,
so
maybe he's busy. I guess he's got a live too, but
okay. Yeah, I forgot that.
People just turn. Yeah, I don't know. Well, not everyone is here.
Yeah, they should be here.
Yeah, exactly.
I forgot.
Where else should they be? Oh dear.
I remember Matteo from the project leaders.
Oh, he wanted to come on stage. Cool. Yeah.
No, I don't know if they want. But I'm just randomly inviting people.
Yeah, I'm typing as I speak, but I've just invited Ishil, who will come shortly to ask a little bit of feedback from our project leads. So she's
So
coming.
Ishil is coming, okay.
Yeah, but she needs to prepare a few things first. So if we have someone else before, then I think that's perfectly fine.
Okay. Meanwhile, should I invite
I don't know
someone else?
Maybe some people.
Sebastian Truger, Katya. Sebastian Truger, Katya, or Sophie, or
I don't know, some people.
I'd really like to hear from people who had issues connecting. So maybe they are not here because they had issues connecting, while those who had issues and eventually got in, what were the troubles? So we know about the emails who got in the spam folders, which is no good.
Yeah.
But is there anything else you think we could have done differently to make it easier for you to join the event?
In the meantime, while we wait for maybe someone to join us, I can tell you that there was one channel in one project I was checking out that's doing fun stuff. Is the one with Farouk, where he's exploding brain. Because they keep posting GIFs of what they've been doing, of how they explode brains. So it's it's a very visually interesting channel to watch. Except that right now, I think it was not really exploding brain, but more like turning them into just goo. If you want to have a browse through their channel, it's very just visually interesting what's going on there. Yep. Sorry, Johannes. Yes, we realized that the crowdcast system is a bit of a just take it or leave it type of approach to invites. So definitely, if you cannot do it just right now, just feel free to just tell us in the chat. Sorry, can't do, but in 5 minutes, that'd be nice to drop by. Yeah, so technically, if you follow the channels, you should get emails before we go live. But because we've had a bit of a schedule, just how to call it, course correction today. It's definitely been I guess you've been getting emails a bit of a weird random time. Sorry about that. Have the platform info more prominent on the website.
Right. I realize it. Sorry.
Yeah, I think we have it sort of hidden somewhere in the logistic page, and then we only put it up at the very last minute on the landing page. Way too late, definitely.
The landing page? Do we have the connection info on the landing page?
We don't have the connection info, but we know where it's going.
No.
We know where things happen.
Yeah, the tricky thing is you want to have the connection info prominent somewhere so that it's easy for people to find, but you don't want to make it public. So in the end, we added it to our private page, but probably now it's at the bottom and would have been better at the top. I think that's a very good point. And it took us a bit of time, like we didn't realize that this would be so much of an issue. And the other one about emails, I think that's the automatic emails from Crowdcast about things going live. Yeah, I haven't followed that quite well, but maybe Remy, you know more. Or Selim.
Yeah, I'm getting the emails as well because I'm following the channel like as myself, and it's true that you get it, and it's like, oh, okay, now I have to just like shift. But that's also why I was trying to make an announcement in our HBM Hackathon channel, just to make sure people know when things were happening. So it's been
emails were kind of automated, but what I really tried to manage things on behind is just to keep things going, because every time I just set the streaming, you can go live, was the most annoying thing, because I needed some time and people were waiting and being confused. Hey Farouk, I just invited you without telling anything.
I just picked up in line.
Yay! We spoke about the exploding brains and just invited you.
Oh yeah, I mean, so we were exploding some brains. I have to say, like there are quite a few more people than I was expecting for this project.
Great.
So it's quite nice. Like we have people implementing the simulations for themselves, or just installing the package and just running it on their own data. It's quite fun. So hopefully I will have some like a bit more fireworks like show for tomorrow.
Cool. Okay. Also, I just want to know what is like the other, except the purely visual aspect, which is awesome. Don't get me wrong. What are some of the other goals you have in mind potentially for this?
Yeah. So this is really actually a first step of a long road that I have in mind, which is basically bringing like particle simulations closer to the brain images. Because I think we are looking at the voxels in a certain way, and this way can be changed, and there are many different ways of looking at it too, and considering voxels as particles almost. I have some like funny ideas about it, but to like I can imagine what I want to do, but to get there, I first need to start with simple particle simulations and then like sophisticate simulations more and more. So for now, it is more like balls moving around, like colliding with each other. But in the future, I would like to add like elasticity, like more jelly-like behavior, and maybe like, I mean, imagine that you do skull stripping, right? And then you can expand the brain and kind of inflate the brain in the volume, in the voxel domain directly, without going into surfaces. I just want to see it, that's So that hopefully in each hackathon I will like add a bit more on top of this, and maybe in some time you will get some volume inflated brains.
Wow.
Okay. Also, I'm just browsing through the channel. You guys have like reinvented Pong pretty much. Is that? Am I getting this correct? Okay. Right.
Wow.
2020, and you're going for Pong. Okay. I like where this is going. This is really retro. I like it.
So I mean, many of this work is done for the visual effects industry. Like we are actually not kind of doing new things. Like I am just like playing around with their algorithm, converting some C++ implementations to Python and learning a bit while doing it, and like adding some little tricks that I think that would be useful. It's just like playground, basically.
Well, that's what a hackathon is also about, right? You're just like, okay, we don't necessarily have like a final like clear goal, or like we do, but in the meantime, we're trying to have fun on the way and learn things ourselves, right?
And another side benefit of brain explosions is that if you are currently frustrated with your papers or revisions or your supervisor, Maybe
Never happens.
a few brains and just de-stress. So that's another serious part of the project, the therapeutic application of the explosions.
Right. Oh, this is fantastic. I love
No,
it.
I just want to join your project and close everything on broadcasting. I just want to jump to your side because it's really fun.
Yeah.
Really cool. Love it. Okay.
Yeah, thanks for inviting me. I don't wanna, sit here and like occupy.
No, that's fine.
We have Ishil wants to pop in now.
Okay, just inviting. Thanks,
Okay.
Farouk.
Thank you, Farouk. I love these brains. Just looking at them, you get a smile on your face. Like,
yeah. This is brilliant. Love it.
Are you inviting her, Celine?
Yeah, she's just accepted and coming in. The connection is taking time behind. So we will see her soon, hopefully.
Cool.
Hey, hello.
Hi,
Ishil. Thanks for being with us.
So Ishil is our awesome hub manager for Europe, Middle East, and Americas. And she wanted, so Ishil, we've invited you because I wanted to discuss a little bit with you the feedback we are trying to gather from people who are attending this event. So, and I think you were particularly interested in getting feedback from project leads, is this correct?
Yeah, so we were doing a similar type of feedback system when we were having Brainhack Global, and we found it quite useful because not all of the project leaders have done this before, so it's new experiences for all of them, and also, I mean, as I am also a quite shy person in general, and even I struggle to approach to the project leaders, and I want to hear about how they found the balance between giving the equal opportunity to all of those attendees, and how did they, I mean, I'm sure they learned quite a lot along the way, but how they are coping with, are they facing problems? Because I was going through the feedbacks we collected in this event so far. I guess some of them wanted to reach some of their participants, but had some struggles to communicate with them as well. It's kind of an ongoing situation, unfortunately, having all those different time zones, having unfortunately some bans over the tools that we are trying to use or to in between. So therefore, it would be really nice to hear this, but I know some people still are not comfortable with giving feedbacks in open environment. So we were discussing with Camille, maybe we can create kind of a formal sheet that everyone write their struggles in a text-based level, or I mean, rather than filling forms anonymously. So, or if they want to share their names or handle this, they can do this as well, and we can gather those problems, and hopefully we improve either tomorrow or for the Americas. Unfortunately, today we already missed for the main festival. We want to solve, I mean, we can't solve everything beforehand or even during the event, but we want to improve us each time, and feedbacks are the most important part of it. Yeah.
Cool.
Thank you, Ishil. Yeah, I think feedback is super important for us. We've tried quite a few things this time, a few new things. We've rushed a few of them. We've been rushing a bit too much in a few of them, but we're trying, and I think that's the important thing. But feedback is like of course, very valuable because it will let us realize some of the places where we could improve. I know connection is one of them. But it would be great to hear from project leads, because obviously in a virtual setup, I think the project part is much different from the in-person meeting. So a conference with talks is maybe a bit easier, like the train track, because at least you have the recordings and you know where you're going. But the project, you have all of these interactions that usually happen quite naturally, that you have to find a structure for, I think, more structure. So hopefully, yeah, if we can get feedback from project leads, that would be super useful for us. I've also pasted in the chat the feedback form Ishil was referring to. So this is a mid-hackathon feedback form. It's pretty short. It's for all attendees, not just project leads. This will be sent to you by email. Okay, well then, thank you, Camille. So Camille is saying that she's not able to submit the feedback form because she's not a project lead. And on the second page, there is a question about project lead. I'm gonna sort this out later, just after this. Yeah, on the fly when someone else is talking instead of me. I can do that. But yeah, thank you for noting that. So true, this was written mostly for project leads, but I would really be happy to hear about like everyone's experience. How has it been so far? And there is a free text at the end. So if there is something that you think is not covered, please just let us know and we'll do what we can. Thank you.
Thank you.
And I think I'll take this opportunity to maybe do also a mid hackathon thank you to all the volunteers. I know that Ishida is on stage, but I would like to thank her. But I would also like to thank all the people who are not going to come on stage, or but who've been doing an awesome job. I know that people who've been fixing our broadcasting issues in the background, been super active on this. All the help desk has been solving plenty of problems, just replying to all the questions we're getting left and right. People on the welcoming desk as well, and the Twitter team. Like I just logged into Twitter earlier today, and I was like, "Oh my God, what has been going on here?" It's just like we're getting a lot of publicity that I had no idea about. So yeah, it's just brilliant how people just take initiatives and go like, "Hey, I'm just going to do this, and we're going to take things that way." It's really great to see all of that happening spontaneously, and people just putting all these efforts to make this. Try to make this a really good event. I'm really happy. Cool. I'll stop and I don't know what's next. Are we inviting someone else on stage?
Yeah, you decide, and I just send invites for you.
I don't know. I'm just. I don't know. Let's see if we have someone else who wants to chat. But at some point we're gonna have to sort of. I'm not sure how we are doing in terms of time. I've lost track of schedule today. That was my big mistake.
Yeah, I think we're a bit over. We were supposed to finish at 3, maybe.
Yeah.
But
okay.
Thank you so
maybe...
much, Michelle. This is so important. I'm really happy you did that.
Thank you. Bye.
Ciao, ciao. I think we should maybe wrap up so that people can go back to a regular thing, or keep on hacking, because I know some people are going to keep on hacking.
Yeah.
So yes, I think this is going to be the end of day 2.
Yes, it's been a really smooth day for my side.
Yeah, I think that compared to yesterday, that was a clear improvement. We are on the it's trending upwards. Let's see how tomorrow is. Yes, we do. Yes. Awesome. Cool. Okay. So bye-bye, everyone, and see you tomorrow for some more fun.
Yeah. See you. And I'm ending the broadcast finally.
Ciao.
Bye.